Hold on to your hats, folks, because we're about to embark on an incredible journey. With the help of super smart scientists and their studies, we've asked AI to take us back a mind-blowing 2 billion years in time and show us what our awesome Earth looked like. So buckle up and let's find out. Once upon a time, way back when Earth was just a baby, around 4.5 billion years ago, hopping into a time machine and paying a visit would have been a big mistake. The whole place was a hot mess. First of all, the ground was still all gooey and molten, so landing your time machine would have been a major risk. Now, as soon as you tried to get out, you would see a completely different Earth compared to what we know today. The landscape is a patchwork of rugged mountains, sparkling seas, and vast stretches of land. Picture massive volcanoes erupting in fiery bursts, shooting gases and ash into the air. It's like a crazy fireworks show. And even if you had a fancy new machine that could hover and had special shields to handle the heat, you'd still have a hard time breathing. You see, the early Earth's atmosphere is a bit moody. Thick clouds hang in the sky, casting mysterious shadows on the land below. The air is as thin as a whisper and filled with all sorts of interesting gases like hydrogen and helium. Carbon dioxide swirls around, giving everything a vibrant green hue. Water vapor drifts through the air, creating a sense of humidity and a refreshing mist. Oh, and there might be a hint of ammonia and methane just to keep things interesting. Lots of cool gases, huh? But wait, there's something missing. Oxygen. So if you take a deep breath, you won't feel that familiar rush of air filling your lungs. On land, there are no lush forests or towering trees just yet. Instead, you find rugged, rocky terrains. Some of these ancient rocks bear the marks of intense forces, collisions and earthquakes that have shaped the land over millions of years. But amidst all this ancient beauty, something amazing is about to happen. Life, in its early stages, is evolving and preparing for its grand entrance. Simple organisms, like algae and bacteria, rule the scene. They thrive in the oceans, using the abundant carbon dioxide to grow and multiply. The waters are teeming with activity, with colorful, microscopic life forms buzzing around like a busy city. These tiny organisms are working hard, releasing oxygen as they go about their business. They're like little factories, slowly changing the composition of the atmosphere. So this is what the early Earth looked like, more or less. But why was it so nasty? And how could it have changed so much since then? You see, Earth's heat came from all sorts of crazy things happening during its formation. First off, there was some serious heat already packed into the objects that came together to make our planet. Then, as Earth grew bigger and stronger, its gravitational force got a major power boost. It pulled in more stuff, but it also gave Earth a massive bear hug, squeezing everything tightly. And you know what happens when things get squeezed? They heat up like a pressure cooker. This crazy heating had a huge impact on Earth's structure. Picture Earth as a mixed-up bag of rocks, metals, and minerals. But as things heated up, the rocks and metals got so toasty that they melted. And guess what? The denser metals sank to the center and became Earth's core, while the lighter rocky stuff floated up to become the crust and mantle. It was like Earth decided to unmix itself, creating separate layers. Scientists call this wild separation differentiation. But the heating didn't stop there. With all this mixing and moving around, Earth got even hotter. It was like turning up the heat in a giant planetary oven. All this crazy heat had some serious consequences. Earth's high temperature made everything super speedy. Tectonic plates were dancing like there was no tomorrow, making the surface super active and full of geological shenanigans. Oh, and that's not all. Earth also got showered by some serious cosmic visitors. Imagine this. While Earth was busy gathering up all sorts of space debris during its formation, the rest of the solar system was causing some major chaos. Saturn and Jupiter decided to shake things up by changing their orbits, sending a whole bunch of massive objects hurtling towards poor Earth. These collisions were no joke. They packed a punch that melted minerals in Earth's crust and even vaporized them. These booms were so intense that they even blew gases right out of Earth's atmosphere. Talk about a wild fireworks show. Believe it or not, we can still spot ancient battle scars from these collisions. It takes some careful detective work, but we can catch a glimpse of their aftermath. For example, there's this place called the Maniitsoq Crater in Greenland. Even though there's no actual crater to see, we can examine rocks that were chilling 12.5 to 15.5 miles below Earth's surface back in the day. And guess what? They bear the marks of intense and sudden shock. Now that's some tough neighborhood. The wildest collision of them all was with a planet called Theia. Theia, about the size of Mars, crashed into Earth with a mighty BAM! It was a colossal event that changed everything. Theia's metal core fused with Earth's core, while the outer layers of both planets got shattered and tossed into space. The result? A beautiful ring of debris encircling Earth. Now here's the coolest part. That debris didn't just float around forever. It started to come together, like puzzle pieces finding their match. And voila, we got our very own moon. Can you believe it? And this incredible moon-making process might have taken as little as 10 years or even less. Crazy, isn't it? Scientists call this whole moon-forming extravaganza the giant impact hypothesis. So next time you gaze at the moon in the night sky, remember that it's actually a huge chunk of our own planet. And by the way, Earth also had quite the adventure trying to create its atmosphere. In the beginning, our planet's first attempt at an atmosphere didn't go so well. It had a thin layer of hydrogen and helium that came along with all the stuff it gathered. But those gases were like sneaky escape artists and decided to float away into space. Bye-bye, gases. Luckily, Earth didn't give up. It went for a second round, and this time it was much more successful. Volcanic eruptions came to the rescue. They spewed out all kinds of gases like water vapor, carbon dioxide, and a whole bunch of other funky ones. Even meteorites and comets joined the party, bringing lots of water and nitrogen to the mix. Earth's atmosphere was becoming quite the party. But here's the funny thing. There was no oxygen to be found during the second experiment. Nope, not a single breath of it. The oxygen that was produced by the sun's rays splitting water molecules got gobbled up by chemical reactions faster than you can say, oxy-bummer. It wasn't until Earth's third experiment came along, life, that things started to change. Photosynthetic organisms took center stage and used all that carbon dioxide in the air to make their food. And guess what? They released oxygen as a sidekick. Eventually, the organisms started belting out so much oxygen that it overwhelmed the reactions, and it began to fill up the atmosphere. It took a while, though, and it wasn't until about 350 million years ago that we got the oxygen levels we have today. About 21% of the air we breathe. So, from fiery volcanoes to mysterious oceans, this glimpse into the past reveals an Earth vastly different from the one we know today. It's fascinating to explore the ancient landscapes and imagine the early stages of life taking shape. Thanks to AI, we can catch a glimpse of Earth's remarkable history and appreciate the wonders of our ever-changing planet. So, stay tuned for more interesting journeys.
This is Earth, 335 million years ago. I wasn't around then, but there's just one supercontinent, Pangaea. See? Let's watch it shift around and fast forward. Okay, here we go. It just split into two huge pieces. Australia goes this way, North and South America go that way. Africa, Asia, Europe, forming, and there we go. The planet as it is today. Let's keep going. I mean, the continents are always on the move. Over time, some of them will crash into each other. Others will break apart. But that'll take about 100 million years. Better put it on super fast forward. 100 years from now, humans keep spitting carbon dioxide into the atmosphere, and the planet's already warmed up a bunch. The world's ocean levels have risen about 4 feet. The Bahamas? They've totally disappeared. 200 years from now, the Earth's population is about 19 billion people. The climate's gotten even warmer. We're packed in like sardines over here. New medical tech makes it possible to live to 180. But why? Fossil fuel reserves of oil and gas? Long gone. Oh, and the continents have drifted over 16 feet. The Voyager 1 space probe's about to enter an asteroid cloud at the edge of the solar system. It's the most distant man-made object in the universe, I guess. 1,000 years from now, thanks to better quality food, humans are now 7 feet tall on average. Technology solved the pollution and fuel shortage problem. Humanity's doing just fine. Robots do all the work. We just play around all day. Ocean levels have crept up another 10 feet. Islands like the Seychelles, Maldives, Galapagos, and many others have gone underwater. Denmark, the Netherlands, Eastern England, Thailand, and Vietnam are only partially underwater. There's been a huge human migration these last 100 years. Fast forward about 5,000 more years, and it's the year 8113. Humanity's getting ready to open the crypt of civilization. It's a hermetically sealed room in Georgia, in the States, bad Georgia. It was created in 1940, and it's full of about 800 books on microfilm, recordings of famous people's voices. It's also filled with bits of technology from that time, like a toaster, a radio, and a typewriter. Some awesome people created the crypt of civilization in case humans experienced a major catastrophe in the distant future and had to rebuild civilization from scratch. We'd all go back to using typewriters. 15,000 years from now, our planet has changed its tilt, and the Sahara Desert is now a tropical paradise. Years of rain turn the dry desert into a wild jungle. 30,000 years from now, the Voyager 1 space probe has finally left the asteroid cloud at the edge of our solar system. If it doesn't collide with anything, it'll be flying in the dark, wide-open outer space for a very long time. 50,000 years from now, the climate's changing a lot. The temperature on Earth is beginning to drop, and we are approaching the beginning of a new ice age. The radio signal with a special "Hello, all you aliens out there" message sent into space in 1974 has reached its destination. The message contained the human number system and data about our DNA and our solar system. If there was someone on the other end to receive this signal, we might have a response from them. 100,000 years from now, one of the largest known stars in our galaxy, Canis Majoris, explodes with enormous force. The explosion of this supernova can be seen from Earth, even during the day, and the nights are much brighter because of the new strong glow in the night sky. What's new on Earth? Supervolcanoes start erupting all over. These volcanoes spew colossal amounts of lava and ash everywhere. Thick black clouds cover most of the sky. This prevents the sun's rays from reaching the ground, and the temperature on our planet drops even lower. Humans mostly live underground anyway, so it's no big deal. Because the stars are gradually moving in different directions, the usual constellations are starting to change shape. Soon, we'll need to come up with totally new constellation names. 250 years from now, a new island's on the map. Back in 2021, it was just an underwater volcano somewhere in the Pacific. After thousands of years of spouting out lava, it finally reached the ocean surface and busted out in the cool, fresh air. Not much growing on it yet. Niagara Falls has long since disappeared, and Lake Erie and Lake Ontario have teamed up to form one huge super lake. 300,000 years from now, the triple star system WR-104 is about to explode. It's spinning crazy fast, and there's a chance that radiation from the explosion could eventually reach Earth. That would do a lot of damage to all life on our planet. Voyager 1 reaches the brightest star in the night sky, Sirius. Not a very funny star at all, it's really Sirius. It's 8.6 light-years from Earth. 500,000 years from now, scientists are pretty sure that a huge meteorite could fall to Earth any day now. It might be even the size of 8 football fields. The impact of such a massive meteorite would cause an explosion so powerful that its sound would be heard on every continent. That would be followed by super strong earthquakes and tsunamis higher than the Brightside Empire municipal building tower thingy. Okay, I just made that up, but who knows what we'll be building in the future. 1 million years from now, the rogue star Gliese 710 comes very close to our solar system. We're surrounded by a huge shield of asteroids called the Oort cloud, and the rogue star is beginning to affect the asteroids hanging out in there. It grabs them, spins them around, and throws them toward the center of our solar system. Comets start to fall on our planet all the time, big ones, causing more tsunamis and earthquakes. 10 million years from now, the Red Sea is gradually expanding into the East African Rift. Africa is now divided in two by a new oceanic gulf. The human DNA molecule has completely decomposed. But it's no big deal. We've become totally digital, without any pesky aging problems. The really cool thing is that other animals have evolved a lot and changed ridiculously. Thanks to a simple interface, we're actually able to talk to dolphins, chimps, dogs, and cats. Turns out cats aren't grumpy, they're just busy contemplating life. 25 million years from now. The San Andreas Fault has been crazy recently and has caused the Gulf of California to flood the Central Valley. There's a new sea on the west coast of North America. 50 million years from now, Africa just collided with Eurasia. The Mediterranean Sea is totally gone. There's a new tallest mountain in the world. Its name? Mount Everest, of course. Australia is continuing its journey north. It already collided with Southeast Asia a few million years ago. The few human colonies still left on Mars need to do some serious packing. Phobos, one of Mars' moons, is beginning to orbit at a lower and lower altitude. That's not good. It's about 14 miles wide, so that's going to be unpleasant. 60 million years from now, the Canadian Rocky Mountains have completely eroded. It's just one gigantic flat plain. 80 million years from now, all that remains of Hawaii is one island. All the others have long since gone underwater. But just next door, a whole new chain of Hawaiian islands has emerged. Finally, 100 million years from now, we made it! The Atlantic shrinking down to nothing. The Americas are almost rubbing up against Africa. Africa's already merged with Eurasia. We've got ourselves a supercontinent again. Hello, Pangaea Proxima. All traces of human life are gone or buried deep underground. The movement of the continents has destroyed tunnels, roads, buildings, bridges. Animals and plants now reign supreme on Earth. So, where are all the humans? Well, remember we made the jump to digital about 90 million years ago? Things are still going strong. There are trillions of human minds living on a huge hard drive on a spaceship orbiting Earth. The super low space temperature is good for keeping the drive nice and cool. We have millions of different societies, languages, and cultures just like we had 100 million years ago. The only difference? We're all little ones and zeros in a huge digital universe that we created. And yes, there's still football. So here's the scoop. You're not even born yet, but your parents already know what you're going to look like. In the year 3021, DNA tech is so advanced they can basically pre-program a person. Eye color, hair, face, and nose shape, lips, finger length, body structure – it's as simple as selecting from a drop-down menu, kind of like creating your own character in an RPG. Everyone looks great. No more diets, no more gyms, and a healthy body for everyone. All it takes is a little gene modification and a special liquid full of a couple of million nanobots. Bioengineering and medtech allow people to change their bodies and minds whenever they want. Improved hearing? Done. Now you can hear a fly rub its paws together from the other side of the room. Not that you'd want to. Nanorobots can turn your eyes into binoculars with 100 times zoom. From your 160th floor apartment, you can read the nutrition info on that wrapper lying on the ground. You've got to get a life, pal. Want to fall out of a window and land unharmed? Nanorobots can make it happen. Millions of tiny robots can be sent to cover your bones and muscles if you want to lift a car with one hand. Superheroes aren't really a big thing anymore. Anyone can get superpowers in 3021. And say goodbye to spending years learning a new profession. You don't need to go to college to find a good job. Just download all the skills and knowledge you need. Medical nanorobots can get into your brain and improve your mood. You can become joyful, angry, funny, sad, all in a matter of seconds. The physical brain isn't a mystery anymore, nor is the subconscious mind. That means no more psychologists or psychiatrists. And solving your personal problems? Easy. You have special lenses built into your eyes linked to AI. You can see an analysis of your mind, and AI will even suggest a strategy for improving it. Not getting enough vitamin C? You'll get a notification. Need more protein? Notification. You'll get it. It's awesome! Amazingly, nanorobots open access to your memories. Watch them like movies, any period of your life, anytime you want. You can see happy moments in perfect detail, or permanently delete anything you'd rather not see anymore. Genetic engineering makes it possible to create not only modified humans, but also animals. Scientists bring back extinct fish, birds, and mammals. You can even grow your very own pet from scratch – a dog, cat, small elephant, dinosaur, whatever you want. And if you don't like cleaning up a mess, pick up a pet robot that looks and acts just like a real animal, without all the annoying stuff. In 3021, your body can live for 200 years, but your mind – forever. You can upload your brain data to the cloud. Your way of thinking, habits, attitude, character, memories, your entire personality can be coded and uploaded. You can encode your mind now and download it into a new, modified body, say after you hit your 189th birthday. And this new body doesn't need food or water, only energy. In the future, no one goes hungry. People travel around the galaxy in style. You can upload your consciousness to a computer and beam it over to your other biomechanical body that you had shipped to another planet. If you've got enough money, you can buy several bodies and scatter them in different parts of the galaxy. Then, on your day off, you can teleport your mind to another planet just to get a bit of peace and quiet. If you want to unload your consciousness and download it again in a few hundred years, you've got a choice to make. Be in a 100-year-long dream, or spend the time flying around in an infinite network. You can even put your mind on the internet and do whatever you want. Some people even choose to live inside the web just for a year or two. Matrix, anyone? People have learned to change their surroundings with the help of utility fogs. Imagine a robot the size of a human cell. This robot has several limbs, can change color, temperature, and can connect with other tiny robots. Utility fogs are just trillions of these little guys. They cling to each other and can create any object you want, or they can turn into a sort of hologram, perfect for video calls. The fog can take on any shape. It can be a cup, a painting, a car, a bigger robot, just not anything living. But just because it's the future doesn't mean everyone gets to have fun. This fog tech is crazy expensive. The fogs can create buildings. You can wake up in your beautiful house, go to work, and the house gets automatically folded up and transformed into a small suitcase. Hey there, George Jetson! You can travel around the galaxy with it and transform it into any home you want. Suddenly feel like having a bigger kitchen, different furniture, a rooftop pool, a slide from your bedroom to the kitchen? No problem. And inside your house, things are way different. You don't have to clean up anymore. Dust, dirt, and grime are all taken care of by nanorobots. You're watching a sad movie, crying, going to town on a Kleenex. Then you just toss the used tissue over your shoulder. Right where it lands, your utility fog turns into a small trash can with wheels. It zips over to the kitchen, dumps out the Kleenex, and poof, it disappears. What about an after-movie snack? For centuries, pizza drones have been flying through the streets. At one point, it got a bit ridiculous. There were too many of them. They started crashing into each other and into passing birds. Now, you just order a sandwich or pasta through your special lenses, and the food gets 3D printed. When resources on planet Earth began to run out, people colonized the Moon and Mars. Then, the big breakthrough – a thermonuclear engine, capable of transmigranuclear flabba. Hey, let's just call it a teleporting device. People sent AI robots over to build cities, roads, electrical grids, and water filtration plants. Then, people began to move there permanently. Everyone born on Mars or the Moon was different from us Earthlings. Mars, for example, gets less sunlight than Earth, so Martians have wider pupils. That means if they ever come back to Earth, they'd basically have night vision. But Martians, and people on the Moon, lunatics, have weaker bones. Luckily, they have those handy nanorobots to help them. But with these new discoveries come new risks and dangers. Uploading your consciousness can go horribly wrong. You risk facing virtual viruses that can imprison you in a virtual cage. Many attackers use programs that can erase your mind, just like a plain old file on your desktop. Those nanorobots, they can still be defective sometimes, and instead of upgrading your body, yeah, not great. Moving to other planets is crazy risky. We sometimes have to abandon cities on Mars because there's suddenly a 300-year-long dust storm. And space travel, sorry to tell you, never stops being dangerous. Even in 3021, there are loads of forces in the universe that scientists still don't understand. Say you buy a modified robo-body and send it to a beautiful new Martian city. You're on Earth, and you upload your consciousness to a computer and send it on over to the new body. The weather is perfect, the sunsets are epic. Suddenly, a huge asteroid smashes into your house. These kinds of things happen in 3021. The way we live now seems exotic to the people of the future. To breathe and live in a natural body, to eat natural food, to take a real water shower, to learn new info by reading, that stuff freaks them out. At some point, humans learn to travel through time, but immediately ban the new technology. Humanity's living in a utopia, apart from the occasional asteroid ruining that robot body you saved up for a whole year to buy, and any change in the past could mean the end of it. Instead of traveling to the past or the future, people create virtual simulations of their favorite time periods. The most popular simulations? Just going back in time and living a day as an ordinary person in 2021. Powerful quantum computers analyze your genes, calculate what you would have looked like, and recreate an exact you. Life was so much simpler 1,000 years ago. Me? I'm going to 1977. Disco, the Bee Gees, glitter balls, the golden age of music. For some of us.
You're inside a small spaceship. You're flying higher and higher, then leave the atmosphere of our planet. Hundreds of thousands of satellites with glowing advertising banners appear in front of you. One of them says, "Happy New Year, 5699. This year you have an anniversary. You will be 5,000 years old. You press a button on the touch panel and activate the ad block. Now you can't see any holographic banners through the glass. You're going to make a jump through space. A black tunnel called a wormhole appears in front of the ship. You fly inside and the hole disappears. The ship has teleported to the Andromeda Galaxy. You discovered an exoplanet here recently, similar to Earth. It's also blue, has a lot of water, but only one huge continent. The planet is hidden in dense interstellar clouds, and you hope that other people won't find it soon. But as soon as it's entered into the intergalactic register, you'll definitely buy this planet. You call it second home. Now you're flying into the atmosphere, going through the clouds, and landing on a small green hill. At the foot of it, you see several small houses made of clay and stone and thatched roofs. Near the houses, locals are working in simple clothes. They're plowing the ground, and cows are eating the grass nearby. You have turned on your stealth mode, so the locals can't see you. They aren't real people. You created them using cloning technology. The conditions on this planet are now the same as they were on real Earth in the year 699, the year when everything changed for you. You remember swimming in the lake at night and looking at the stars. One star moved from its place and began to approach. A huge flash of light and something heavy fell into the water. You lost consciousness and woke up in the morning on the shore. Only 1,000 years later, you realized it was a meteorite. The day after the star fell, you noticed that any damage on your body instantly disappeared. After a couple of decades, you realized that you get older slower than the rest of the people in your village. After another 50 years, you understood that you didn't age at all. Knights, Vikings, the Dark Middle Ages, the geniuses of the Renaissance. You see it all with your own eyes. You become an emperor of a huge empire, and then you get bored and decide to live in the slums to feel all the shades of this life. You think that some magic gave you immortality, but then you realize that any magic or sorcery is really science. You communicate with the greatest minds on the planet, make friends with incredibly bright people, and really bad ones to understand the nature of humans. Around the 15th century, you've got all the knowledge and read all the books that people could give you by this time. You begin to explore the world yourself. You discover the process of photosynthesis in plants, grasp the fundamental laws of physics, conduct amazing chemical experiments, and find out that you live on a tiny planet in an infinitely vast universe. Biology, chemistry, physics, astronomy, you learn and explore everything. The results of your scientific research in these subjects are ahead of humanity by 100 years. While the whole world is riding horses, you're already building a car with a steam engine. To hide your identity from people, you constantly change your name and place of residence. Over 1,000 years, you have learned all the languages of the world, and even those that no longer exist. You study all the psychologically known personality types. Your social and emotional intelligence is so developed that you can create a person's portrait after 1 minute of talking to them. You look into their eyes and understand what they want, are afraid of, or are ashamed of. You spend several years in continuous meditation to calm your mind and gain wisdom. You lead the life of a hermit and watch humanity slowly develop. But then, the 20th century comes, and the life of the entire planet changes dramatically. The Industrial Revolution, the first cars and trains, cinema, radio, and television. In these 100 years, people are changing more than they have in the previous 1,500 years. Now, it's hard for you to keep up with the world. New inventions appear every day and every hour. The knowledge and experience of previous years help you become one of the most influential people on the planet. World leaders listen to your opinion. Thanks to your developed communication skills, you can negotiate with any person. You go through expensive and high-quality plastic surgery operations so that no one will recognize you. You keep moving and getting a new ID every 20 years. You have a lot of money, as well as gold and other valuable metals that you've collected for centuries. You build houses and shelters in the most beautiful places on the planet. You finance the development of new technologies. Sometime in the 1950s, you predict that in the next century, there will be a unique network that will allow you to store all the knowledge of the world in a small device. With the help of this network, all people will be able to communicate with each other from different points of the Earth. You're surprised that the internet appears much earlier. Developers create virtual reality worlds with photorealistic graphics. Artificial intelligence is smart enough to rule a small country. Genetic engineering allows us to clone people and mix our bodies with robots. The first cyborgs appear. With each passing century, there's less and less space on the planet. You get tired of people and consuming new technologies, and you spend more and more time in your home on the top of Mount Everest. Humanity is taking over Mars and the Moon. Soon, these places aren't enough for people too. In the 4th millennium, scientists create a quantum engine to travel through space. You're among the first people to try this technology and make the jump to another group of planets orbiting a star similar to our solar system. Your ship breaks down and you can't go back. You're left to live alone on a new planet. Your body adapts to the conditions on it, so you don't need oxygen reserves. Then, you learn to breathe without oxygen at all. The cells of your body receive what they need for normal functioning from the surrounding gases. Your skin is getting rougher because of the dusty atmosphere of the planet. And with the increased gravity, you develop incredible strength. You'd become a super person with such a body on Earth. You manage to send a signal into space, and you hope that humanity will catch it. You've been living alone for over 500 years without books, the internet, or any communication. You spend most of the time exploring a lifeless desert world. Using parts and tools of the ship, you create a vegetable garden. You also have a lot of water reserves. During all this time, you realize that you miss the old world and your life before the meteorite fell. Some spaceship picks up your signal and comes for you. You return to your homeworld. Travel between solar systems is now as easily available as travel by subway or bus. You decide to find a planet as similar to Earth as possible to recreate human life there. Using the power of modern telescopes and your knowledge of astronomy, you discover what you've been looking for in the Andromeda Galaxy Nebula. You arrive at the second home and live a human life there. For hundreds of years, you observe people and mentally go back to your past. You protect those people from external threats, like asteroids, but don't interfere in their lives. From time to time, you fly to Earth and other planets for business. Life on the second home is becoming very similar to life on Earth. There are more and more people and cultures. Technologies are emerging. You have completed your goal, and now you want to discover other worlds. You spend the next 5,000 years studying the ever-expanding universe.
A space settlement floating out there in the cosmos. It's not sci-fi. But, as always, there is a catch. Look at this tiny deserted asteroid. It may look lonely and barren, but if you peek inside, you'll see life blooming inside of it. These days, many people now live right inside these asteroids. It's not sci-fi. According to researchers, we might be able to create futuristic cities the size of Manhattan on gigantic space rocks. Of course, there's a catch. The asteroid we choose as our base has got to be at least 1,000 feet wide. Though it's weird why life is inside this asteroid and not on its surface. You see, we can't really live right on asteroids. That's because we're not the little prince who indeed lived on an asteroid, according to the plot, but because there's too little gravity and too much radiation for us to handle if we chill outside. There are possible theoretical ways to stay on the surface, but it's going to be extravagant. So the only option is living inside asteroids. Nothing screams wildly theoretical like building an asteroid city. Living in space without any gravity isn't as romantic as it sounds. Researchers show that when people spend too much time in zero gravity, things start getting weird. Their eyeballs pop out, retinas detach, muscles shrink, and bones become as fragile as a potato chip. But imagine this, a space settlement floating out there in the cosmos. If you've watched enough sci-fi, you'd picture a massive structure spinning round and round. It spins to create gravity for all the lucky folks living inside. There's an actual prototype of this wizardry, the O'Neill cylinder. This device is named after physicist Gerard O'Neill, who came up with the idea for NASA in the 70s. Now, there isn't a ton of data on this, but humans need roughly 1/3 of Earth's gravity to function properly. An O'Neill cylinder may not be able to generate massive amounts of gravity, but the genius behind it, Mr. O'Neill himself, designed them to spin around their long axis. This device creates a gravity-like force called centrifugal force. So, if we ever get to use that, we'll be living happily on the inner surface of the cylinder, feeling pulled downward away from the center. But, as always, there is a catch. When the team crunched the numbers, they realized that the asteroids would break apart way before they could reach the speeds necessary to keep us grounded. And to make matters worse, most of these asteroids were more like loosely assembled piles of rock than a solid chunk. The small ones, like less than 6 miles across, are a mix of sand, pebbles, rocks, and boulders. They're all held together by the weak force of their own gravity. If you were to spin one of these asteroid buddies, all those parts would go flying off into space. Not cool. However, scientists didn't give up and they elaborated on the idea. They needed to find a way to keep the asteroids together. They played around with different ideas and they produced something crazy. Now, if you were to carry all your personal belongings every day right in your hands, at some point, the situation would be out of your control. You'd have to collect all your stuff from the floor. But you're smart and you carry a bag, right? Well, it seems that if we want to control an asteroid, all we need is a ginormous bag. But not just any bag, a massive, flexible, and super lightweight mesh bag made from teeny-tiny carbon nanofibers. These fibers are like tubes that are only a few atoms wide, but boy are they strong. So once we've got this cylinder-shaped bag all set up, we can start slowly spinning the asteroid using rocket motors deep within the rubble. And as it spins faster and faster, it'll start flinging all those pebbles, rocks, and boulders. And guess what? The carbon nanowire webbing is going to go flying out with them. This bag will be expanding and expanding until it reaches its absolute limit. And then the rubble inside slams into the now super tight webbing. It's like a crazy explosion of debris compacting together to create this massive hollow cylinder made entirely of concrete. Once all the dust settles, you can build entire towns, cities, parks, and even farmland on the inside of the cylinder. This is like something straight out of O'Neill's designs. You can even enclose the whole inner surface with a transparent roof. Outside of this incredible living area, you've got these thick concrete walls that are like superhero shields protecting against radiation. So not only do you have this space to live in, but you're also super safe from any harmful stuff outside. We still don't have this magic bag, as those magic carbon nanowires aren't mass-produced yet. But scientists claim that, according to the laws of physics, a tiny asteroid, like a few football fields put together, can be transformed into 22 square miles of living space. As of now, about 1.5 million people are living in Manhattan, and there are like tens of thousands of asteroids just hanging around in our solar system. You do the math. Seems like everyone will have a sweet spot to crash in space. Building a city in space is no easy feat. The main challenge still is to create a self-sustaining closed system that can keep going for the long haul. You see, cities on Earth rely on a much larger area to survive than just their own boundaries. But in space, the farther away from external resources a space city is, the more it needs to close its loops for oxygen, water, and food. Take the ISS, for example. It's about 40% efficient in recycling oxygen, but even then, its CO2 levels are always sky high. NASA is on the case, though, trying to figure out how to magically turn that CO2 back into oxygen. Once we've tackled the basics, like protecting ourselves from radiation, dealing with pesky gravity, and finding some air to breathe, it's time to get creative in space. Enter 3D printing and rocket engines, the dynamic duo that will pave the way for space settlements. With 3D printing, we can kiss goodbye to relying on Earth for spare parts. We'll simply whip them up locally, cutting out the middleman. We can even use 3D printers to whip up a delicious pizza in a couple of minutes. Of course, we'll need some fresh ingredients, but your dinner might just be a push button away in space. To truly thrive out there, we'll need to tap into the riches of asteroids. These celestial treasures are bursting with raw materials, perfect for creating solar arrays, building materials for our colonies, and so much more. And let's not forget about comets. These icy wonders are like cosmic water fountains, providing us with precious H2O for drinking, bathing, and even shielding ourselves from radiation. Plus, we can use that water to produce hydrogen and oxygen for rocket fuel and fuel cells. So, let's say we pull this off. Can you imagine people living or born in space might end up being different from you and me? Like if humans can have babies up there, these space colonies might develop some cool cultures. They might even come up with their own languages, and get this, they could even evolve new physical traits. It's wild to think that just after 300 years, a colony of 2,000 people could look and act so differently from us. They might have different hair textures, skin types, and even be taller or more slender to deal with that low-gravity situation. We might even develop new organs to protect us from cosmic rays. Or we'll have gill-like structures to breathe carbon dioxide. Hey, I know, it sounds crazy, but these scientists are working on developing these carbon nanotubes as we speak. So maybe one day we'll be living it up on our very own asteroid crib. It might seem like asteroid cities are just too far-fetched, but let's take a trip back in time for a moment. In 1900, no one had ever flown in an airplane. But today, thousands of people are zooming through the sky, comfortably seated in chairs, traveling at hundreds of miles an hour high above the ground, unaware that their luggage is on another plane going to a different destination. Ah well.
Have you ever wondered how cool buildings of the future are going to look? Well, hold on tight because artificial intelligence is here to revolutionize the world of architecture. AI is a great sidekick. It can give the architects incredible new tools to create mind-blowing structures that are not only stunning, but but also eco-friendly and super efficient. So let's check what our beautiful future might look like. First of all, you know how cities can get crazy busy and overwhelming, right? Well, guess what? AI is here to save the day and make our cities super smart. Imagine you're cruising down the road in your flying car. Yes, we'll have those. Thanks to AI, the traffic flows like a dream. No more endless gridlock. The city knows where the most likely crime spots are and takes proactive steps to keep us safe. It's like having superheroes on every corner. And hey, forget about trash piling up. AI makes sure waste is managed efficiently, keeping our city clean and fresh. They can act as a city manager who can optimize everything from traffic to safety and even waste disposal. They can analyze tons of data from all sorts of places like sensors and social media. With all that information, they can help city planners make brilliant decisions that make our lives better. Okay, so you stroll down the street, and your eyes are instantly captivated by an extraordinary building. Its futuristic curves and features make it stand out from the rest. And it not only catches your eye, but also gives Mother Nature a high five. You might think it was designed by a genius architect, but little do you know it was actually a collaboration between humans and artificial intelligence. Imagine having a super smart design buddy who can whip up thousands of incredible building ideas in a blink of an eye. That's what AI-assisted design software does for architects. It can generate and assess a ton of design options. They take into account stuff like the best materials to use and the perfect placement for the building. Also, by analyzing data and crunching numbers, algorithms can help optimize the building's design. They can ensure it minimizes energy usage, conserves water, and manages waste like a pro. Every building strives to reduce costs, save energy, and promote a better world. The result? Architectural masterpieces that are both jaw-droppingly beautiful and super practical. The cityscape of the future will be dotted with these awe-inspiring structures. Oh, but that wasn't impressive enough for you? Well, how about a stunning, futuristic building that seems to defy gravity? It's not made of traditional bricks and mortar. Oh no! This marvel was created using the powers of 3D printing. With the help of AI, architects designed every intricate detail and fed all the important data, like what materials to use and how the site conditions might affect the structure. AI algorithms worked their magic to optimize the design, making it both breathtakingly beautiful and rock solid. 3D printing is basically like having a magical machine that can create awesome structures straight out of a sci-fi movie, and AI jumps in to make sure these structures are not just pretty, but also strong. In the city of the future, 3D printing will become the ultimate architect's tool. It will allow them to create structures that were once impossible to build. From mind-bending shapes to intricate details, the possibilities are endless. But AI isn't just making buildings look great, it also makes them efficient and cozy. Let's say you step into a futuristic office building, and voila! The lights automatically adjust to match your mood, and the temperature is set perfectly for you. These futuristic buildings are capable of sensing and responding to their surroundings, just like you do. They control the lighting, keeping it just right for the time of day. They manage the temperature, so it's always cozy and comfortable. They even keep a watchful eye on security and fix small issues before they become big headaches. So, the smart building knows when people come and go, so it optimizes energy usage accordingly, saving the planet and some cash along the way. Now the cool thing is, all these aren't the only possibilities. How about turning skyscrapers into a vertical forest? Recently, an architect from India got super excited about the power of artificial intelligence. So, he decided to team up with an image bot called Midjourney to create a vision for the future. But instead of a dull, robotic world, they aimed for something spectacular. With text prompts like utopian technology and futuristic towers, the architect and AI got to work. Guess what? Midjourney didn't disappoint. It conjured up a world where buildings were covered in lush vertical forests and adorned with shapes inspired by nature. They wanted to create a sustainable future that harmonized with the environment. The architect, Manas Bhatia, is super positive about AI's potential. He doesn't see it as a threat to his job, but as a powerful tool for positive change. He envisions a future where architects and AI collaborate to make breathtaking designs. In his project, Bhatia even asked the AI to imagine symbiotic and hollowed structures. and it responded with pictures of apartments nestled within hollowed-out trees. Imagine a world where the building itself becomes a living, breathing part of nature. Well, Bhatia believes that nature should play a big role in architecture. He loves designing structures that embrace nature's beauty and functionality. From buildings built around trees to facades that regulate temperature, he's all about blending architecture with the natural world. With architects like Bhatia and the superpowers of AI, the future of cities is going to be amazing. So get ready to step into a world where nature and technology coexist in perfect harmony. It's a dream we can't wait to see come true. Or if you're not a big fan of trees, how about this? Skyscrapers that aren't made of solid bricks, but instead, they're inflatable wonders. Zumo, an architectural practice in Barcelona, used the magic of AI to bring these wobbly structures to life. These inflatable superstructures rise above future cities like illuminated balloons in the sky. Here's the best part. These inflatable buildings have sustainability superpowers. You can pump them up to towering heights, flatten them for easy transportation, and rebuild them wherever they're needed. Plus, they're powered by renewable energy, reducing their impact on the environment. Pretty cool, right? Phew. The future is zooming toward us like a rocket. Artificial intelligence can become the secret sauce that makes architects' work extra special. But hey, with great power comes great responsibility. We need to use AI wisely and ethically. For now, we don't have to worry about machines replacing architects. Artificial intelligence still needs a human hand, or else we might end up with buildings that look like mashed up bananas or ice cream cones, unless that's your thing. In addition, humans have one important advantage. They, well, are humans. We need to keep in mind that artificial intelligence doesn't have emotional intelligence. It's a brainy genius, but it can't fully understand the feelings and vibes we humans crave in our spaces. So, we must remember to infuse our designs with that human touch, those warm and fuzzy elements that make us go, "Ah, I feel right at home." And let's not forget that AI is still learning. It's basically just taking its first steps, and we need to be patient and give it time to grow. Rushing things too quickly could lead to wonky designs or buildings that look like a jumbled puzzle. This might look cool if you like avant-garde architecture, but for regular folk, no thanks. So, as the future unfolds at warp speed, let's embrace the wonders of AI in architecture. But let's also remember to balance its brilliance with our own human touch. Together, we can create a future where buildings are not just functional, but also filled with heart and soul. It's an adventure that's out of this.
Look up when the sky is clear at night. You'll see thousands of tiny bright dots there. It may seem like they're fixed in one spot, but in reality, they're constantly moving. In 100,000 years, there won't be a constellation with the same shape or pattern we know today. And think about all those red dwarfs, small stars, planets, space bodies we can't see with the unaided eye. Red dwarf stars are especially cool. They're usually about half the size of our sun, and mostly 1/10 as bright. They may not be the brightest things in the sky, but they live for a very, very long time. Nuclear fusion reactions happen deep in star cores. That's what makes them shine. Large stars release huge amounts of energy, burning their stellar fuel. But such stars tend to burn all their fuel in only a couple of million years. Stars like our sun usually live for about 10 billion years, but red dwarfs don't use that much of their fuel. Their light is not so powerful, and they don't require much energy to support their existence. They're like energy-efficient cars. That's why they can last hundreds of billions of years. Some of the smallest ones may live for up to 10 trillion years. Most hydrogen in sun-like stars remains unspent. There's more of this gas in the atmosphere rather than in the core of such stars. This means most hydrogen doesn't take part in the fusion reactions. But it's different with red dwarfs. They circulate plasma throughout their entire bodies. These stars pull fresh hydrogen reserves from their outer layers into their core. That's what keeps fusion reactions running. One day, in the distant future, stars like our sun will run out of fuel and shut down. The universe will be full of small red dwarfs. They won't have enough energy to shine and brighten the space around them. Our descendants, if there are any, will inherit a dim, dark cosmos. As it gets older, the sun will balloon to a size where it will destroy nearby planets. First Mercury, then Venus, and then us. On the other hand, Earth will probably survive, but barely and not for long. The sun will burn it to a crisp when it gets closer. The outer planets of our solar system will also survive, but they'll move even farther away into space. The sun will lose some of its mass while increasing in size. Its gravitational pull establishes the orbits of the planets. When our star becomes less massive, the pull of its gravity will become weaker, and the outer planets won't have such a strong connection with the sun. Our solar system is not isolated. There are many other stars in our galaxy. Within 30 billion years, stars that travel nearby will mess with our outer planets, enough to rapidly launch some of the biggest ones out of the solar system altogether. The last planet to stay will stick around for a while longer, maybe even 100 billion years. But even that one will eventually end up kicked out of the solar system. There's a theory claiming that we got most of the water on our planet from ice-laden meteorites and comets, frozen balls of ice and dust. As they crashed into the early Earth, they probably brought water, which was necessary to develop life. But those very same objects that might have created life on our planet could also be its end. This is not a matter of if, more a matter of when. And scientists think it's very likely that an asteroid or comet big enough to wipe out life on Earth will smash into our planet. But it'll happen in the distant future. And fortunately, we have the technology to predict such things and react on time. But there are other cosmic collisions we can't avoid, no matter what we do. Andromeda, our neighboring galaxy, is moving toward the solar system at a speed of 68 miles per second. There are 2.5 million light years between the Milky Way and Andromeda, so luckily our neighbor won't cover that distance anytime soon. It'll only happen in around 4 billion years. Such a collision of two galaxies might lead to real chaos for our descendants, if any of them are still living on Earth, that is. The two galaxies will slide past each other. Then they'll draw apart until the gravitational force starts pulling them back together. As they merge, they'll both lose their disk-like structure and form one big elliptical galaxy. It's already got the nickname Milkomeda. The Milky Way as we know it today won't exist anymore. Space is in constant motion, changing all the time. Scientists have a couple of possible scenarios of what might happen with the universe in the future. Number 1, the Big Rip. This theory claims that the universe will expand infinitely. At one point, the pull of the expansion will get stronger than the gravitational force keeping it all together. If this happens, it will tear apart galaxies, stars, black holes, and all other space bodies, including Earth. The universe will turn into a bunch of disconnected particles. Until about 5 billion years ago, the universe was expanding slowly because of its powerful gravitational pull. Then its growth sped up. Some experts say it happened because of the effects of dark energy. Dark energy is a mysterious force that makes up almost 70% of our universe. This force pushes it to expand faster rather than slowing it down. So, in the case of the Big Rip scenario, dark energy will win over gravity to the point where it will be able to rip apart individual atoms. Scenario number 2, the Big Crunch. There's a possibility the universe will get to the point where it'll stop expanding. Gravity will become a dominant force. It might even reverse the expansion of the universe. Then, the cosmos will start shrinking, making planets, stars, and even entire galaxies collide. In the end, the whole universe will collapse in on itself. Once everything compresses into one infinitely small point, which is something called the Big Crunch, the universe may start expanding once again. Theory number 3, the Big Freeze. Brr. In this scenario, entropy will grow until it reaches its maximum value. Entropy is basically the idea that everything in the universe declines into disorder at some point. Once entropy gets to its maximum, the heat in the system will be spread evenly. The universe will then disappear because there won't be any room for heat to exist. Any mechanical motion inside the universe will stop. The cosmos will be so empty and gas will be so thin that no new stars will be able to form or shine again. In such a cosmos, time is just an endless void. Nothing ever happens with planets, stars, or living beings. The entire universe is frozen, dark, and motionless because there's no energy that can make things start working again. Many, many billions of years after the last stars burn out and fade, black holes will send a message that the universe has come to an end. Black holes are areas with extremely strong gravitational pull. so powerful that nothing can escape it. They can be as massive as 100 suns. As for supermassive black holes, their mass can be greater than that of 1 billion suns. You can find such giant black holes at the center of most galaxies. Like everything else, black holes will experience the same end. But when their moment comes, they won't gently disappear into the night. Black holes will go away in enormous bursts of fireworks, lighting up the universe in the last moments of their existence. It will be the end of the entire era. Black holes usually survive by gobbling down the stars and gas that come close enough. Their gluttony is the main feature that gives them away. In most cases, there's an accretion disk around a black hole. That disk is made of all those materials and particles it's torn apart and is pulling inside, similar to when water swirls down a drain. As the materials and particles draw closer, they start to move faster and faster. This generates heat, which makes the accretion disk glow, which again gives away the black hole. Yep, black holes aren't that great at hide and seek. Things that cross a black hole's event horizon, which is also called the point of no return, are lost forever. But Stephen Hawking had a theory that you might be able to escape from a black hole. There are particles moving even in a vacuum. Let's say one particle has positive and one has negative energy. If they both come close to a black hole, there's a chance that one will fall into it while the other will escape. That means the black hole has radiated the particle away. And this particle has taken some of the black hole's mass with it, which is why the black hole may start shrinking. As it begins to evaporate, it loses its mass and slowly becomes smaller. More and more particles start leaving until all the energy that's left behind escapes all at once. In the final tenth of a second, there will be a giant flash of energy and light in a very, very small region of space. And then, it's all gone.
Imagine that it's the year 2025, and our planet has completely changed. Rising sea levels, extreme weather, and the ocean becoming more and more acidic are just some of the problems people have been dealing with for years. But in one of the world's largest coastal cities, the situation has become too serious. It was a sunny day in June when a massive earthquake shook the city to its core. The ground beneath people's feet heaved and shook, and buildings swayed dangerously. People ran through the streets in panic, trying to find safety. But as soon as the ground settled, the inhabitants of the city realized the real danger. A wall of water, almost 100 feet high, was rushing toward the city, propelled by the force of the earthquake. The tsunami hit the city with unimaginable force. Entire neighborhoods were wiped out, and thousands of people lost their lives. But here's where things get interesting. In the aftermath of the disaster, the city's authorities realized that they couldn't just rebuild the city as it was before. They needed to be better prepared for the next potential disaster. And so they came up with an incredibly ambitious project to build an underwater city. The goal was to create a self-sufficient, sustainable city beneath the ocean's surface that could withstand any natural disaster. The underwater city would be powered by renewable energy, using tidal power and underwater solar panels. It would be designed to withstand extreme weather and would have its own emergency response systems. The project attracted some of the world's top scientists, engineers, and architects. They worked tirelessly to design the city and carefully considered every aspect of the project. The underwater city would have everything that a typical city had, from schools and hospitals to stores and restaurants. There would be underwater farms where fish and other marine creatures could grow. The city would even have its transportation system, advanced submarines, and underwater tunnels connecting different parts of the city. The project became a shining beacon of hope for people. It showed that even in the face of disaster, we could come together to create something amazing. But as time went on, the project no longer seemed so perfect. The cost of the project turned out to be higher than planned. There were also concerns about how long such a project would exist. After all, the ocean is very unpredictable. And still, the team of scientists and engineers never gave up. After years of trial and error, they finally created the perfect underwater city, a marvel of engineering, a self-contained ecosystem that could sustain people indefinitely. The buildings were constructed from a material that could withstand the immense pressure at the bottom of the ocean, and the city itself was powered by a network of advanced hydroelectric turbines. It wasn't long before the first wave of colonists arrived at the underwater city. There were different people in this group, and each of them had their own reasons for choosing to live in this new world beneath the waves. Some were adventurers seeking a new world to explore, while others were hoping to escape natural disasters raging on dry land. But despite their differences, all these people shared a common goal: to build a new society, one that was in harmony with the natural world. The underwater city flourished, and new discoveries were made every day. The colonists developed new technologies and ways to tame the power of the ocean. They learned to farm the sea and started cultivating underwater gardens that provided them with a steady food supply. But living underwater was challenging. People felt isolated and even claustrophobic. The situation came to a head when a group of activists started to protest against the city's expansion plans. They argued that the underwater city was a threat to the environment it was meant to protect, and that the colonists should focus on reducing their impact on the delicate underwater life. The protests sparked a heated debate among the colonists. Some of them argued that the survival of the city depended on its growth and expansion. Others claimed that the city needed to prioritize the protection of the environment above all else. In the end, a compromise was reached. The city would continue to expand, but the main priority would be sustainability and a responsible attitude to nature. The colonists would do their best to reduce their impact on the environment by using new technologies and following strict conservation rules. And they would also remember the importance of protecting the ocean and its fragile ecosystem. Years went by, and the underwater city continued to thrive. New generations of colonists were born, and they grew up in a world entirely different from the one their ancestors had known. They never saw the world on the surface, but appreciated the beauty and complexity of the underwater world they called home. And as the years passed, the city became a symbol of hope for a world struggling with the devastating effects of climate change. It showed that despite all difficulties, people could come together to create a better world. It is a reminder that the future is not set in stone, and that we can build it sustainably and in harmony with the natural world.
This planet's called the jewel of the solar system. Made up mostly of gases, it could float on water, should you find a reservoir 75,000 miles across and just as deep. But what makes the planet so recognizable is its beautiful rings, gray, tan, and beige. They consist of dust, rocks, and ice. Some bits are as tiny as grains of sand, others as large as skyscrapers. The planet I'm talking about is Saturn, and right now, Earth is hurtling toward it at breakneck speed. It all started on a regular day over half a year ago. All of a sudden, Earth changed the course it had been following for several billion years. But instead of rushing towards the Sun, it started to move away from the star. On second thoughts, it might be for the better. We've got more time to find a solution. Earth used to move around the Sun at a speed of 67,000 miles per hour. For some mysterious reason, when it left its orbit, the speed remained the same. It means we're going to cover 746 million miles, separating our planet from Saturn within a year and 3 months. At first, no one realized what had happened, but a couple of hours later it became obvious. Despite the panic that engulfed Earth's inhabitants, nothing seemed to be out of the ordinary. But all too soon, it started to get colder and colder. Astronomers' forecasts were pessimistic. People started to leave their homes at the poles, move closer to the equator. Most plant and animal species were having a hard time. Some of them went extinct, even though we were trying to save them in greenhouses and special conservation parks. The sky changed dramatically. In a week, we could see Mars clearly. It looked like a big reddish sphere hanging low over our heads. Jupiter became as bright as the moon. Once Earth was as far away from the Sun as Mars, days became twice dimmer than they used to be. At first, our planet's atmosphere was acting as a barrier between people and space. That's why we didn't feel the cold immediately. But 7 days later, everyone who dared to leave their home had to be cocooned in heavy winter clothing. By that time, the temperatures had already dropped down to minus 145 degrees Fahrenheit. It got even colder once our planet passed Mars and hurried through the asteroid belt. It's been one of the most dangerous regions on our way so far. Yes, people could admire awesome meteorite showers streaking the sky. but several space bodies managed to get through the Earth's atmosphere. They slammed into the ground, flattening mountains and leaving behind gigantic craters. They caused tsunamis and triggered earthquakes. Right now, most of the planet, including the oceans, has already turned into an icy desert. There's a lack of food and natural resources. We've built underground towns and tunnels connecting them. Our scientists work day and night to find a way out of this situation. If they don't, that's what's going to happen. The closer our planet will be to Saturn, the more the ringed planet will loom over the horizon and the larger it'll look. Soon, it'll already shine brighter than the full moon. The massive yellowish-brown orb will be visible even during the day, but it'll look especially impressive at night. Instead of sleeping, millions of people will spend hours watching Saturn grow larger and larger. One day, the distance between the two planets will become the same as the distance between Earth and Mars used to be. Saturn's disk will be about a quarter the size of the full moon. Its rings will be as large as 2/3 of our natural satellite. Soon after that, our planet's speed will start to increase under the influence of Saturn's gravitational pull. The ringed planet is 9 times wider than Earth, and its mass is almost 100 times greater. That's why, instead of moving at a speed of 29 miles per second, we'll be dashing through space at almost 40 miles per second. That's 2,400 times the average car speed. Saturn's gravity will influence the moon more than that of Earth. In no time, we'll lose our satellite. It'll get catapulted into outer space, likely to go into an elliptical orbit around the Sun. If Earth wasn't about to crash into Saturn in the nearest future, the Moon could one day cross paths with our planet again. No good would come out of such an encounter. But what's happening on Saturn's side of things? Saturn is one of the largest planets in the solar system, second only to Jupiter. Even though the rings surrounding the planet are huge, they're rather thin, less than a mile thick. Still, the main rings are large enough to stretch from Earth to the Moon. But how did the planet get these breathtaking accessories? Beyond the outer edge of the main rings, A, B, and C, there's something astronomers call the F ring. Several million years old, it's the weirdest one. This constantly shifting ring is made up of icy material and is incredibly complex. Its curves, twists, and clumps of brighter substance make it look as if it's braided. Saturn has more than 50 confirmed moons. 2 of them, Pandora and Prometheus, flank the F ring on either side. They weave outside and inside the ring, acting like shepherds. They herd ice particles into a 60-mile-thick band. But why are they performing this elaborate dance? No one knows. What scientists do know is that when Saturn's rings were evolving, icy material clumped together and formed moonlets. Some of them grew and turned into the planet's largest moons. But 2 of them collided. That's how the mysterious ring F appeared. If the moonlets had only been made up of small icy particles, the space collision would have left a ring and nothing else. But they had dense rocky cores. Those remained intact and turned into Pandora and Prometheus. People don't have any evidence Saturn's ever collided with another space body. Our Earth might be the first. But before crashing into the planet itself, we'll have to get through its rings, including the ring F. And no, our planet won't just punch a hole in them. Saturn's rings are made of small particles. Earth's gravity will start to pull some of them out of their orbit once we're close enough. It'll result in a long plume that will reach our planet. And later, when we squeeze through, the cloud of icy particles will drag after Earth. It won't have enough power to rid Saturn of its rings completely, though. They'll continue to move around their home planet, but their orbits will change and become more elongated. There will be no more stunning bands. Over time, the rings could probably settle down again, but Earth won't give them such a chance. The collision with our planet won't leave Saturn unscathed. If there's still a possibility to sneak a peek at the sky, people will be able to see the rings disappear into nothingness, but not for long. Soon, the largest chunks of rock will start hitting the surface of our planet, leaving behind lifeless land dotted with craters. In the worst-case scenario, Earth might even collide with one of Saturn's numerous moons. But let's imagine we've passed through this region in one piece, and now our planet's very close to Saturn. The gas giant might seem airy, but there's no way Earth can fly through the huge sphere and leave from the other side. Gravity is what keeps all that gas together. The very gravity that make our planet speed up. The closer it is to the much bigger space body, the stronger the pull is. It'll cause the fault lines on Earth to rupture. It'll also set off powerful volcanic eruptions all over the world. And then, with enormous force, our planet will crash into Saturn. The planet's atmospheres will get compressed. This will cause a dramatic and fast temperature rise, and in no time, the air will be on fire. Scientists claim that Saturn's core is dense, made up of iron and nickel, and surrounded by a rocky layer. But we'll never make it there. Earth will burn in the bigger planet's atmosphere after being literally torn apart. Our beautiful, blue-green world will turn into billions of trillions of tons of vaporized rock. Pity. Maybe Earth will become yet another Saturn's ring, instead of the ones it's ruined. Sounds grim, I know. Yeah, we can't save Earth from Saturn, but that's only a bad dream. So, maybe we take that effort and save us from a real threat, climate change. Just saying. So, you're driving down the highway, and an 18-wheel tractor-trailer is coming up fast behind. You've got to change lanes. You look in the mirror. Is there enough space? And you notice the words on the mirror. Objects in the mirror are closer than they appear. No kidding! Well, it's the same with the Milky Way galaxy. There's another galaxy headed this way, and like the tractor-trailer, it's closer than it looks. The Andromeda Galaxy, or M31, as it was labeled originally by Charles Messier in his catalog of 110 fuzzy objects in 1774, is now officially named NGC 122, that's New Galactic Catalog 122. A spiral galaxy larger than the Milky Way, the Andromeda Galaxy is so big and so close that you can see it without a telescope. In fact, it appears with the unaided eye half as wide as the Moon. It's estimated that the Andromeda Galaxy contains 1 trillion stars, compared with the Milky Way's estimated 300 to 400 billion measly stars. To see the Andromeda Galaxy, you must allow your eyes to become dark adapted. This might take about 10 minutes while your pupils dilate to take in as much light as possible. M31 is best seen from late summer through winter, when the great square of Pegasus the Winged Horse is overhead. Draw a line across the great square diagonally upwards from the lower corner star, then go a little further beyond the square. There it is! But you still won't be able to see how big it is unless you peek at it from the corners of your eyes. If you stare straight at it, the galaxy will tend to fade away. You must use your peripheral vision to see how big the Andromeda Galaxy appears. Peripheral vision, or averted vision, allows you to see light more sensitively at night, but without color. Sailors have used averted vision for centuries to see faint lights out on the ocean or on land. Aristotle used averted vision to observe star cluster M41 in Canis Major, as he described in his book Meteorologica. In a telescopic photograph, the Andromeda Galaxy appears 6 times wider than the Moon, because with the unaided eye, we can only see the bright center of the galaxy. A telescopic photograph shows how massive M31's spiral arms really are. And this beast of a galaxy is headed our way. We are looking at a future massive collision of galaxies of, well, galactic proportions. When that happens, humanity may need to relocate to another galaxy to inhabit. Perhaps we'll go to the Pinwheel Galaxy in the asterism of the Big Dipper. How do we know the Andromeda Galaxy is moving towards us? With a tool called a spectroscope. After the camera, the spectroscope is the most important attachment to a telescope. Oh, except for the human eye. Our eyes only see light. You don't have this big horse in your eye. You only have the light being reflected by the horse in your eyes. The same with space. We only see the light coming from there. So, if we are going to understand space, we need to understand light. And that was not an easy task for astronomers of the 19th century. The invention of the spectroscope was a big breakthrough in understanding light coming to Earth from space. With a spectroscope, astronomers can tell which direction objects in space are moving, as well as which elements are making the light. When you hear an ambulance approaching, you hear the siren getting louder and higher, and when it passes you and goes away, you hear the siren's sound get weaker and lower. The change in pitch frequency depends entirely on the motion of the source. This is called the Doppler effect, after the Austrian physicist and mathematician Christian Johann Doppler, who first explained the effect in 1842. The ambulance siren is not changing its volume. The sound waves are being compressed as it is approaching and stretched as the ambulance recedes. The spectroscope shows that light waves show the same Doppler effect as sound waves. They are compressed as the star or galaxy is approaching us and appear stretched when it is receding. Therefore, the light from an approaching galaxy will appear slightly bluer, the blue shift, a slight increase in frequency, and the light from a receding galaxy will appear slightly redder than normal, or red shift, a slight decrease in the light's frequency. In 1929, Edwin Hubble, after whom the Hubble spacecraft is named, published his spectroscopic study of 46 galaxies, the light from all but one of which was redshifted, moving away. Hubble's study provided the first evidence that the universe was expanding. The farther away a galaxy was from the Milky Way, the faster it was moving away. This was also the first evidence that the universe began with a Big Bang. The one galaxy whose light was blue-shifted, moving towards the Milky Way, was M31, the Andromeda Galaxy, the closest galaxy. 250,000 miles per hour seems a pretty high speed at which to have a collision. That's the speed spectroscopic measurements of the blue shift of Andromeda indicate. It's going to be a big mess when it happens. But when is it going to happen? To determine when the two galaxies will collide, we need to determine the distance between them. And for that, we need, boom, supernovas. Type 1a supernovas are what are called standard candles. Just as we know how bright a candle shines, we know how bright a Type 1a supernova shines, its absolute magnitude. A Type 1a supernova appears when a white dwarf collapses under the pressure of all the gas it has been gravitationally slurping from a companion star. Looking at the Andromeda Galaxy and measuring the apparent brightness of a supernova in the galaxy, it is possible to calculate its distance away from us. Because the intensity of light dims inversely with the square of its distance away, which is called the inverse square law, by comparing the apparent brightness of a supernova in the Andromeda Galaxy with its absolute brightness, well, we get an approximate distance of 2.5 million light-years. Since 1 light-year is approximately 6 trillion miles, and the Andromeda Galaxy is 2.5 million light-years away, even though it is approaching at the speed of about 250,000 miles, we have about 4 billion years before the big collision. So you can wait until after lunch, maybe dinner, to start packing. As an aside, if we see the Andromeda Galaxy as it was 2.5 million years ago, and it has been moving toward the Milky Way all this time, how big in the sky would it appear now? Quite as big as that tractor trailer in your rearview mirror. But do we really have 4 billion years before the galaxies crash? There are several other factors to consider. The minor galaxies that are gravitationally linked to both the Milky Way and the Andromeda Galaxy will be swallowed up by their host galaxies. Considering the lopsided mass distribution that will result, the galactic collision of the Milky Way and Andromeda will be affected. Some scientists are saying it won't be a direct hit, but more of a sideswipe. And then there's the galactic halos of each galaxy. Here's what Project Amiga has found out about the halo of stars and gas surrounding the Andromeda Galaxy. Using the Hubble Space Telescope, researchers were able to observe how the light from bright distant quasars were being absorbed by the mostly invisible gas around the Andromeda Galaxy. Look at the results. Notice M31 in the center. If the same is true of the Milky Way, and there's no reason to think it would be different, then the halos of the two galaxies are touching now. The collision has already begun. There is also a question about what effect the dark matter clouds around each galaxy might have on an impending collision, or are having now. But enough of speculation. In 4 billion years, the Sun will have increased brightness on its way to becoming a red giant star. And humans will have already found another galaxy to inhabit. Happy traveling, dear humans! You're relaxing in your room and streaming some good tunes when suddenly the network's down. You try rebooting your phone, but there's still no connection. Out of nowhere, your sister barges into your room in panic. She's screaming something about rings. Boxing rings, wedding rings, rings on the tub. She's not making any sense. So she drags you out of the house and shows you the sky. You take a look up and see streaks of objects forming miles above the Earth's surface. Her connection seems to work. The two of you check online what's going on, and everywhere the same thing is making headlines. Rings are suddenly appearing in our sky. #EarthRings is breaking the record, and videos are going super viral. Your sister can't help but join the crowd and takes a bunch of selfies with the sky. You run to the TV in your living room to check out the news. Scientists are warning about a coming catastrophe and explaining that everyone should remain indoors. Even though it's a cloudless day in the middle of summer, the weather seems to be getting colder and colder. Suddenly, the signal's cut off. Other channels show nothing either. Then you see your neighbors packing their bags and heading out. Others follow suit. You hesitate a bit, but decide to do the same in the end. Your sister is still outside taking selfies when you urge her to come along with you to seek some answers. The two of you hop in your car and drive out into the city. The rings above seem to be gaining more mass with each second. You and your sister are getting colder and colder. You head to the university to see if anyone knows anything, but there's no one there. Only one parked car in the lot. And it's a good thing you recognize that car. You and your sister rush in and find the astronomy professor doing some quick calculations and trying to figure out why all this is happening. He urges you to take seats and begins explaining. No one knows what this is all about, but it's limiting the sun's exposure on Earth, which explains why it's getting colder by the minute. Why the rings are getting thicker is a mystery too. On Saturn, the rings are made up of ice and rock particles. They can be as small as an ant or the size of a bus. The rocks could be leftover meteor debris or even remnants of dwarf planets. But since Earth is so close to the Sun, ice wouldn't be something you'd find floating above us. With all these rocks piled up, they block the Earth's access to Sun to warm us up and give us light. The professor goes on to explain that Earth will enter a new ice age, and oxygen levels will deplete within a year's time unless those newborn rings disappear anytime soon. This also explains why there's no connection. The rocks that form the rings are hitting and breaking the satellites. Suddenly, you hear a loud ringing noise outside. The three of you head outside and see a helicopter blasting an alarm with a red light flashing.
Everyone to your homes now. This is not a drill. Everyone, head home.
You get in your car with your sister, but the roads are jammed. You have to go on foot, which will take 2 hours. There's no way anyone can remain outdoors. You venture out seeing everyone stuck on the road. They're all arguing with each other and causing chaos. You try not to get caught in the middle of anything and sneak your way to the highway. With the rings getting thicker, less sunlight is breaking through. This ice age info is stuck in your head, chilling you even more. You take a deep breath and see a thin mist coming out of your mouth. The sky is getting darker and you're still not home yet. Your sister is tired and needs to rest, but you urge her to move on. You find an abandoned clothes shop and head inside. The store clerks are actually giving away thick jackets for everyone to wear. You grab a couple and slip them on. Only 1 more hour to get home, but the sky is completely dark. There's no way you and your sister can go out in such conditions, so you decide to camp up in the clothes shop. They set up a mini bonfire in the middle of the shop and create makeshift sleeping bags with the rest of the unused clothes. Luckily, there's enough food to feed everyone, including you and your sister. It's the middle of the night. The fire goes out and you can't see outside the shop. You head to the window and open it up. A huge pile of snow spills in and wakes everyone up. It's the middle of August, and a snowstorm formed overnight. Everyone is freezing, and they start the fire anew. There's no radio or any way to find out what's happening. The wind picks up and starts shaking the shop. Things start falling off the shelves, but you and everyone else are cozy by the fire. The next day, you look outside and see the entire area covered in snow. You live in a sunny place where it barely rains, and the rings in the outer atmosphere are even bigger than last night. Out of nowhere, a truck filled with people pulls over, and the driver tells you there's a shelter for everyone some miles away. The truck has chains all over the tires and is equipped for the worst snowy conditions. Even though it's morning, the sky is pretty dark. You and everyone else hop in. Abandoned cars, some with their doors still open, are scattered all over. The truck drives around them or just smashes through the ones in the way. It pulls over next to an ambulance and takes all the equipment to help the ones in need. You drive past your neighborhood and see your entire house covered in snow. The large tree in your backyard has fallen under the weight of the snow and broken the roof, allowing snow to flood in. The truck speeds through and gets to the shelter, which, to your surprise, is the mall. You get out and see many of the townspeople being led to various stores that have now turned into dorms and health units. You're left in a sports store with a bunch of other people. Your sister has also been able to bunk with you, and to your luck, you see the professor helping out some people. But shortly after that, a loud explosion blasts through the mall and shatters glass screens. Everyone ducks for cover. You see people running outside. You head out and see a large metallic object lying in front of the mall entrance. There are people crowding the entire area, so it's not easy to see what all the fuss is about. But after getting a closer look, you find out it's a satellite fallen from orbit. It crashed in the front yard and made the boom. There were also reports of other satellites crashing on Earth in the most random places. That means all communication has been wiped out of the map. You run back inside the mall to await what happens next. You look at your sister in fear, not knowing that the new Ice Age has just begun. One year later, you're relaxing in your bunker when your sister barges in, freaking out. The rings are still there, but it's something else now. You run outside and see everyone gathering around and looking at the sky. Within a year, temperatures have dropped to freeze the entirety of the Earth's surface. Deserts and tropical jungles have turned into icy wastelands. More than half of the wildlife went extinct, and trees are as rare as a four-leaf clover, which means oxygen levels have dropped significantly. Most of the population, or what's remaining of it, live with oxygen tanks, with scientists still trying to crack the case of the rings. Exactly what the professor predicted. But up in the sky, rocks seem to be falling down and crashing all over. It starts off far away, but then the rocks begin to fall down close by. You and everyone else run back into the mall, which has been covered with a layer of metal to keep the warmth inside. It should be pretty safe in there. If the rocks are falling down, that means the rings are dissipating. Suddenly, you're full of hope that the Ice Age might be over soon. Now, there are things about nature that you know for sure, or don't you? Let's check how much you know about the incredible world we live in. How many of the 14 points will you guess? Let us know. The Great Pyramid of Giza was built when mammoths still roamed the earth. Myth or fact? It's actually a fact. The most famous pyramid in the world had been constructed about 500 years before woolly mammoths went extinct, approximately 4,000 years ago. Their last known habitat was the cold and deserted Wrangel Island in the Arctic Sea, which might not have been as cold then as it is today. There are more trees on Earth than stars in the Milky Way. Is it myth or fact? It's a fact. Scientists used to believe there were about 4 billion trees on our planet, but more recent studies have shown that there are over 3 trillion of them, making it 420 trees per person. As for the stars in our galaxy, there are only about 100 billion, which is 30 times fewer than the trees on Earth alone. The trees you see are all individual ones, myth or fact? This is false. In fact, 90% of the trees on Earth are interconnected by mycelium filaments. They send warning signals when in danger and exchange nutrients through them. It's kind of like the underground internet. Also, there are organisms like Pando, for example, which is the largest single living being on the planet. It looks like a dense forest of quaking aspens. In fact, it's basically a single giant tree, with its roots being interconnected underground. We drink the same water dinosaurs used to drink hundreds of millions of years ago. Myth or fact? Actually, it is. Only a small portion of the water on our planet has evaporated for good. The rest of it is constantly renewed. So, mammoths, dinosaurs, and whatever came before them billions of years ago drank and swam in the same water we see today. Not to mention what else they did in the water. Unfortunately, the water doesn't keep information about those ancient creatures for us to find out more about them. Lightning never strikes the same place twice. Are you willing to bet on that? Myth or fact? If you aren't, good for you. Lightning may strike the very same spot as many times as it wants. It might seem random, but the electrical discharge from the sky is pulled toward the tallest objects in the thunderstorm area. Also, the material this object is made of matters too. It's by no chance that lightning rods on buildings are mostly made of copper and aluminum alloys. These metals are some of the most conductive materials, so they pull lightning very efficiently. All deserts are hot. Now, this one's easy, right? Myth or fact? If you guessed it's a myth, then right you are. Deserts are qualified not for their temperature, but for the presence or absence of growth and life in them. The most well-known desert is the Sahara, of course, and it is indeed very hot. The actual largest desert in the world is Antarctica, which is almost twice the size of the Sahara Desert. And you wouldn't call it even lukewarm. It's a polar desert, and there are several others on our planet. For example, Greenland. There's enough gold underground to cover the entire planet in a thick layer. Would you believe that? Well, you should, because it's true. Since 1950, humanity has mined nearly 200,000 tons of gold. If we made a cube out of all this metal, it would be 70 feet high and wide. Recent data from scientists confirm that there are huge reserves of gold in the Earth's core. The metal is enough to cover the whole planet, and people might have gold up to their knees. The problem is, we just can't mine it from there. Hey, I don't mine if you don't. The Moon and Mars are better mapped than the Earth's oceans. Now, this can't be true, can it? Actually, it can. We have a detailed map of the Moon and Mars, although we're still discovering surprises on their surfaces, granted. Still, over 80% of the Earth's oceans are unmapped and unexplored. We can't study the oceans properly because of pressure, cold, and lack of light underneath billions of tons of water. The lava is always red. What other color can it be, right? Myth or fact? Myth. Usually lava is really red or orange because it's basically molten rock from the deep bowels of our planet. But there's one volcano in Indonesia whose lava is blue and luminescent. Only at night though. During the day, it looks normal. No mystery about it, just tons of sulfuric gas. This volcano also has the largest acidic crater lake in the world. The water there is so turquoise, you want to jump in immediately, but you probably guessed you should never do that. The fire on that volcano is also blue, the largest blue fire in the world, rising up to 16 feet high. Ever seen a gas stove burning? Here, the principle is basically the same. You can see a rainbow at night, too. Is it myth or a fact? It's true, and there's even a name for this phenomenon, a moonbow. Also called a lunar rainbow, this event occurs extremely rarely. It's similar to a regular rainbow, except when it appears on a clear moony night after a rain shower. There's a thing called a fire rainbow, myth or fact? You bet! It's a beautiful phenomenon when the clouds in the sky are painted all the colors of the rainbow, looking like a fiery, multicolored cascade. It only occurs when the conditions are right, and those are very specific. It's close to the equator, the weather is clear, there are feather-like clouds in the sky, the sun is higher than 58 degrees above the horizon. Such clouds are made of ice crystals. When the sun's rays hit them, the particles refract the light and create a rainbow. Wow! There are rainbow trees, myth or fact. If I made you doubt this, I'm glad, because this one is not photoshopped. This is the rainbow eucalyptus, and their bark may literally have all the rainbow colors. These eucalyptuses shed their bark at different times each year. Every time the old section goes off, the tree first reveals bright green bark that was hiding underneath, and then it may turn any color. There's a whole set of hues: orange, maroon, blue, even purple. Stones can move on their own. Myth or fact? Well, you'd be right to believe me. There's a desert plain in California where rocks move around of their own will. Once this plain used to be the bottom of a lake, but then it dried out and became an arid wasteland. Sometimes rains fall here, flooding the entire valley. When night comes, the temperature drops and the water is covered with a thin layer of ice. When it gets warmer again, the ice breaks into segments and the wind pushes them around the place. Some of these ice shards take small rocks with them. When the ice melts for good and the water evaporates, the only thing that remains are trails left by the rocks, as if they'd moved on their own. Mud puddles can move around. Myth or fact? In fact, a single mud puddle in the world also travels as it wants, and nobody still knows why. It moves at a pace of about 20 feet per year, and it seems to have started its journey near the San Andreas Fault in California. People have tried to stop its march, but couldn't. So far, this creeping natural disaster isn't showing any signs of stopping on its own either. So, there's your pesky, problematic puddle to ponder. Bang! Another hit on Jupiter. Let's see. Gas giant, the largest planet in the solar system, 318 times bigger than the Earth, 2.5 times bigger than the rest of the planets in the solar system put together. One more interesting thing. If it got any bigger, it would actually become smaller. You see, with more mass, the planet would be denser. That would cause Jupiter to start pulling in on itself. Scientists say Jupiter could have 4 times greater mass, but still keep the same size. It takes 10 hours to make a full rotation on its axis. It's the fastest spinning planet in our solar system and gets hit by so many space objects all the time. This was discovered by amateur astronomers observing Jupiter and saw some unusual flash at the planet's surface. Impact events cause flashes like that, and for some reason, Jupiter gets more impacts than other planets. In 1994, astronomers discovered Shoemaker-Levy 9, a comet that broke apart and collided with the gas giant. The original comet was approximately the size of one that erased the dinosaurs. However, this asteroid fell apart into more than 20 fragments. They darkened the planet's surface, and it remained like that for months. 15 years later, in 2009, astronomers saw a black spot on Jupiter, the size of Earth. It was the result of an asteroid around 650 to 1,650 feet in length. The biggest asteroid recorded on Earth hit the area of Tunguska, Russia in 1908. This caused a massive explosion, even though no one ever found a crater. So, why is Jupiter the target for so many space objects? Asteroids and comets that pass by Earth and Jupiter go almost at the same speed. The number density of the space object that may interact is almost the same too. But the cross-section of what they might hit is very different. Jupiter has 11 times the diameter of our planet, which means it has around 125 times the cross-section. The more massive some planet is, the stronger its gravitational attraction. So, it will entice some space objects drifting by. Our gravitational field is weaker than Jupiter's. If some object passes near us moving at a speed of 22,300 miles per hour or less, our gravitation will attract it. Asteroids and comets usually move at bigger speeds. Jupiter attracts most of the comets and asteroids passing by. If our planet was hit by such big objects as frequently as Jupiter, we'd have extinction like with dinosaurs thousands of times more often. In 2020, scientists found there was an unusual asteroid in the orbit of Venus, the first one there. The size of a small mountain and rich in minerals we can find in Earth's deep rocks. They even think it could be a clue to a bigger set of asteroids created when our solar system was forming. That's not the only mystery around Venus. The planet has insanely violent winds that drive clouds and storms around the planet at speeds greater than 220 miles per hour. That's 60 times faster than Venus itself rotates. Also, scientists are still not sure what happened with its oceans. They believe since the planet is so close to the sun, the water evaporated and went into the atmosphere as steam. It trapped heat coming from the sun, heat that would have vaporized more and more water over time. Venus probably had an environment like on Earth, but a very long time ago. The theory says many comets and asteroids were slamming into Venus. Billions of the planet's pieces were flying all around. Some may have even crashed into Earth's moon. Pieces that slammed into our planet are probably buried very deep, since we have greater geological activity than the moon. Uranus also had a collision, but a more serious one than asteroids. The rest of the planets in our solar system mostly have an axis of rotation that kind of points up from the elliptical plane. Uranus is tilted, lying on the side, so a season there lasts 42 years, when either its south or the north pole is pointed at the sun. Most of the planets also rotate counterclockwise when you see them from above our solar system. Venus does the opposite, which means maybe it was kicked off axis a long time ago. Uranus may have collided with the other space body millions of years ago. When our solar system was still very young, the orbital configuration of Saturn and Jupiter may have crossed. Their gravitational forces kind of created orbital momentum and transferred it to Uranus. That knocked it off axis. Millions of asteroids orbit the Sun, and not so many pass by Earth from time to time, so we don't have some dangerous space bodies coming toward us. The plan is to visit Mars in the 2030s, and scientists hope Mars won't be a target of some bigger space bodies. New craters are formed on the red planet every 1 to 2 days. They can be 13 feet across, which means they could have been formed by objects that are the size of a soccer ball. Since the atmosphere there is thinner than ours, smaller bodies can enter easier. Most of the Martian north is smooth lowlands. The south is higher, full of craters, and the planet's interior has a surprising amount of rare metals. The theory says this is because a big celestial body collided with Mars and tore away a part of its northern half. Debris from that asteroid circled the planet and then mixed into 2 small moons that orbit Mars. We also have some Mars rocks on Earth, found in the Sahara Desert, Antarctica, and some other places across the globe. Some of these rocks have gas that's chemically the same as the atmosphere on Mars. Rocks probably came due to a big explosion that happened when some larger asteroid or meteor that was ejected from Mars and landed on our planet. Mercury also has a thin atmosphere, so there are many smaller strikes there. Imagine waking up, going to your window, and see there are micrometeor showers every morning, which is something that happens on Mercury. This strange weather pattern shapes its atmosphere, called an exosphere. Mercury is so dense, its heavy iron core accounts for 2/3 of its total mass. Scientists think it could have been bigger in the past, but many collisions got the surface sort of scraped off. It's been constantly bombarded by rocks from space that left marks with craters. Plains on its surface seem to have been created because of volcanic lava spilling over the surface and then dried smooth. Many craters are filled with such a material, which means there's one more thing that rocked Mercury's world: volcanoes. There's an unusual group of asteroids discovered near Neptune. Wide range in sizes, from big metropolitan areas to tiny pebbles. They are thought to come from an asteroid group called the Kuiper Belt. It makes a ring well beyond Neptune. But these new asteroids have different colors than the Kuiper Belt. They're so far away from the Sun, their surface was supposed to stay almost pristine, but they have a similar color to those sun-baked asteroids around Jupiter. Like the rest of the planets, Neptune gets heat from the Sun. But there's something mysterious inside the planet that makes it generate more heat than it gets. This affects its weather, and Neptune has the weirdest weather in the whole solar system. Massive storms, insanely high winds, cirrus-like clouds that rapidly change all the time. There are dark spots in its atmosphere. They come and go. We receive 1,000 times more sunlight than Neptune. Gas giants like Saturn and Jupiter can protect our planet from asteroids. Without them, the big impacts that created enough debris to form both moons and other planets would happen more often. There's a huge asteroid going around Saturn, which could be a potential flyby by 2031, more than 10 times bigger than the asteroid that erased the dinosaurs. Titan, one of the moons orbiting Saturn, 80% more massive than our moon, is actually the only moon in our solar system that has an atmosphere. It's 1.5 times thicker than ours and consists mainly of nitrogen, like our atmosphere. No one knows where all that nitrogen came from. However, unlike Saturn and most of the other places in our solar system, its moon has a real potential to host life.
Recently, Chinese scientists discovered something interesting on the moon, an unusual crystal. Moreover, they found out that this crystal contains an element that can literally replace nuclear fuel. Let's find out more. The composition of the moon has long remained a mystery to us. Half a century has already passed since the Apollo mission. Unfortunately, we haven't traveled to the moon much since then. So it's not surprising that it's not so easy for us to study it. But recently, we've made a breakthrough in this area. In December 2020, Chinese scientists sent the Chang'e 5 probe to the moon. The mission was named after the ancient Chinese deity of the moon, Chang'e. Quite poetic, isn't it? Anyway, after the probe went to the nearest side of the moon, it spent several days digging through the surface and rocks and then returned to Earth. In total, it collected about 4 pounds of various lunar rocks, like basalt, solidified lava, and so on. And yeah, maybe it doesn't sound too impressive, but it's actually a mini breakthrough. After all, we hadn't received any lunar samples since 1976. And these samples are very important for learning the history of our world. We've been struggling for many years to find out, for example, how the moon was born at all. Yes, there were a lot of theories, but we still couldn't find any proper evidence for any of them. But thanks to the latest missions and some computer simulations, scientists finally found out the truth. The moon was born when some random dwarf planet crashed into our Earth many millions of years ago. This dwarf planet was slightly smaller than Mars. The fragments of the Earth went into space, but some of them stayed in our orbit. Then they stuck together and formed the moon. It sounds horrifying, but in reality, the birth of the moon was the best thing to ever happen to our planet. If it weren't for this beautiful satellite, all our oceans would be small puddles. Life wouldn't have appeared on Earth at all. So this is already an amazing discovery, but that's still not all. Studying the collected rocks, scientists from the Beijing Research Institute discovered something unusual, a rare lunar crystal. Looks pretty boring, doesn't it? Just some tiny transparent monocrystal about the thickness of a human hair. We've already found such things on the moon before. These crystals were formed as a result of volcanic activity, just like some garnets on the Earth. And yep, the place where they discovered these crystals also suffered from volcanoes 1.2 billion years ago. That means that this tiny baby is over 1 billion years old. But that's not the most important thing. It's the fact that this crystal is made of a unique material, the one that we've never seen before. Researchers from the International Mineralogical Association have confirmed that such a composition can't be found anywhere on Earth. The crystal was named Chongasite, again after the same moon deity. And this is another achievement. This is the 6th previously unknown mineral that we've found on the moon and the first one found by China. Now, it has become the 3rd country in the world to make such a lunar discovery. However, this tiny crystal still wasn't the only remarkable thing they found. After studying this gem and about 140,000 other lunar particles, scientists have discovered something else. They found helium-3. Why is it so important? Because this is one of the elements that feed the sun and other stars in our universe. We tend to say stuff like, put out the sun is burning, and so on. And this is one of the reasons why many people actually think that the sun is a huge fireball. But it's not. Its burning is actually a completely different process, which is called nuclear fusion. The process itself is quite simple. During this reaction, hydrogen in the star turns into helium. But this simple process is actually one of the most violent and insane reactions in the universe. There's a real boiling broth of particles inside the sun. The hydrogen nuclei that jump and rush there are constantly repelling each other since all of them are positively charged. And so they could continue to boil and chill around without bothering anyone if it weren't for the stars. The stars turned out to be cheaters. They have such strong gravity that they basically grab billions of these little atoms and squeeze them together. Combining with each other, these atoms create new heavy elements, like the mentioned helium. And when this happens, they throw a lot of energy into space. And that's how the sun burns. At the same time, it spreads so much energy that we can't even imagine. Okay, so what is helium-3? Well, this is an element to which even the sun can say, "Whoa dude, you should calm down." The fusion of helium-3 atoms releases even more energy than in typical nuclear fusion. And most importantly, it doesn't pollute the atmosphere with harmful things like radiation. We have very, very little helium-3 on Earth. Its prevalence in our atmosphere is about 1 in a million. And besides, it's constantly trying to escape from us back into space. Probably feels some bad vibes from us. However, scientists have recently found out that there's a place that contains a lot of this element. Yep, you guessed it, it's the moon. We think that there's more helium-3 on the moon than on Earth because of the solar winds. The sun has been hammering on the moon with its helium-3 for billions of years, so now it's all over the place. It's still not too much if you compare it, for example, with Jupiter or Saturn. But don't forget how much energy it can release. For your information, with only 25 tons of helium-3, it's possible to provide America with energy for an entire year. Now, there are 35,000 tons of it here on Earth, and more than 1 million tons on the moon. Only these sources could feed the entire US for thousands of years. So basically, in the future, helium-3 may become a new source of fuel. And it's better than nuclear fuel in basically everything. Helium-3 won't leave any harmful waste and radiation. It's more powerful and not that dangerous. In other words, this environmentally friendly and efficient energy could be a revolution for our planet. Sounds cool, huh? So, what are we waiting for? Grab the shovels, you might say. But there's a little problem here. Unfortunately, we haven't yet come up with anything as wildly strong and hot as the stars. To use helium-3, we need crazy temperatures and pressure. We need a thermonuclear reactor, and we have no idea how to build it, yet. And even if we could heat it up to such temperatures and get the needed pressure, we still don't really know how to handle helium-3 correctly. Therefore, even if we have an infinite amount of helium-3, we still won't be able to use it. But still, there's a great power behind helium-3, so it's not surprising that different countries have already started a race for nuclear resources. Now that Chang'e 5 has discovered a new helium-3 deposit on the nearest side of the moon, this race can become downright global. For example, China already plans a new lunar mission in 2024, Chang'e 6. During this mission, they want to collect the first samples from the far side of the moon. As you can see, finding this lunar crystal was very important for us. These crystals can help us find new ways to create helium-3. And if we manage to do that, humankind will enter a new era. But to do this, we still have to solve a number of problems. How to deliver a bunch of these lunar crystals to Earth, how to make them produce energy, and so on. Let's hope that in the future these issues will be resolved and we'll find a way to produce clean, safe, unlimited energy.
It's becoming colder by the minute. The temperature drops below zero very quickly. And although there's no snow, the cold is becoming unbearable. Hoarfrost appears on the ground, the grass, and the trees, and ice forms on bodies of water at an incredible rate. Shivering people all over the planet raise their eyes to the sky. and their jaws drop in disbelief. The sun has become twice as small as it used to be. It now looks like a distant speck, and it won't be able to heat the Earth any longer. But the worst thing is, there's a huge blazing rock coming right at the horrified spectators from the sky, and the impact with that thing will undoubtedly do a lot of damage. Okay, let's go back to our objective reality. The Earth is exactly in the sweet spot of our solar system. It's neither too close nor too far from the sun, making the temperature on our planet not just tolerable, but rather pleasant. Scientists often call Venus, the second planet from the sun, our Earth's evil twin, because it's so hot and inhospitable that no life is possible on it. Of course, there are thick clouds in its atmosphere that rain acid, and the greenhouse gases raise the temperature on the surface to unbearable values. But even if Venus didn't have those, nothing would still be able to live there because of the proximity to the sun. If there was any liquid water, it would evaporate too quickly, leaving life no chance to develop. On the other hand, Mars, going next in line after Earth, is a bit too far away from the sun, which makes it cold and lonely. The temperature on its surface is below freezing, and it never warms up enough for water to stay liquid for long. That's not to mention the lack of atmosphere on the red planet, the element that provides the Earth with breathable air. So, if our planet shifted closer to or farther away from the sun, its temperature would either rise or fall respectively. A few hundred miles wouldn't make much difference. The circling of Earth around the sun is uneven anyway, and we constantly get nearer to our star or fly a bit away from it. The distance that would matter is measured in millions of miles. And yeah, just like I showed you at the beginning of this video, we'd see the sun a lot smaller than we do now if we went that far. The temperatures might not fall at the exact moment of the shift, as there would still be some warmth left. But in the following winter, our planet would probably stay cold forever. The oceans would be covered with ice, and the overall sea level would drop. And ultimately, the ice would reflect more of the sun's heat back into the atmosphere and space, not allowing the surface of our planet to get the necessary warmth. And more ice means less water vapor in the atmosphere. Water vapor captures heat too, creating clouds. So the colder it is, the less rain. The cold and the lack of rain would not let any plants survive for long. So the areas of icy and barren landscape would grow fast, leaving only the areas along the banks of rivers intact for a while. After some time, the rivers would stop running too, either frozen or dried out because of losing their sources, lakes and seas, which would, of course, freeze as well. Any life dwelling near them would disappear. Plants first, and with them, everything else, since plants produce both food and breathable air. And with that, the Earth would become a frozen wasteland. As for the giant blazing rock I mentioned, it was an asteroid coming from outer space because of the shift of our planet's orbit. Jupiter, the largest planet in our solar system, acts as a natural shield for us against space rocks. It has a huge mass, and most asteroids flinging from outer space get caught in its gravity and fall on its surface. There's no life possible on Jupiter, and its surface is gaseous, so asteroids tend to disappear in it without a trace. Still, some manage to get past Jupiter, where Mars comes into play. It also contributes to our defense by holding the asteroid belt between itself and Jupiter in place. The two planets' combined mass creates a gravitational field that doesn't allow the asteroids from the belt to fly in random directions, hitting everything in their path. If there was no Mars between us and the belt, we'd be used to meteor showers almost more than actual rains. Say the Earth has replaced Mars in its orbit, and now we're hundreds of millions of miles farther away from the Sun. The mass of the Earth is more or less similar to that of Mars, so the asteroid belt is still in its place. The temperatures will still fall though, and life will soon go extinct. But if Mars stayed where it is, and the Earth just shifted away, it would be a recipe for disaster. There's no chance the planets would orbit the Sun at the same rate because their mass is not equal. At some point, they would collide with each other. Taking their speed into account, they'd both crack and shatter, perhaps creating another asteroid belt in our solar system. It would be no more hopeful for us if the Earth decided to jump closer to the Sun. Apart from the star seeming more like a giant, pitiless, blazing ball in the sky, its heat would melt the glaciers on our planet, making sea levels rise abruptly. The water would flood major parts of the continents, and more surfaces of the planet would be covered with water, which means more heat absorption. That would bring about a further rise in the temperature. Also, those large bodies of water would evaporate like crazy, releasing tons of water vapor and carbon dioxide into the atmosphere. Carbon dioxide is a greenhouse gas that absorbs heat, and so does water vapor. Together, they would trap more and more of the sun's warmth, creating thick, roiling clouds in the sky, almost like on Venus, but without the acid. And that thick blanket of clouds would also contribute to heating the surface of our planet. In the end, the entire Earth would heat up so much that life on its surface would become unbearable for most. Only the sturdiest of creatures would be able to survive temperatures so high, those that dwell in our deserts, for example. Despite the rainfall, which wouldn't cease as in the cold scenario, plants would still have difficulty adapting to the new and hot environments. The ones in the cooler regions of the planet would be the first to wilt and go. But then, plants from the moderate and finally tropical climes would also give up. And, yet again, the Earth would turn into a barren ball of rock, only this time an overheated one rather than frozen. Our planet's distance from the Sun, its tilt, its speed of rotation around its own axis, its orbit around the Sun, and even the presence of the Moon in its skies, all of that is crucial for life on Earth to exist. For instance, if the planet wasn't tilted relative to the Sun, it would be unbearably hot on the equator and impossibly cold at the poles. The seasons would also stop changing, dividing the Earth into strips of endless summer and winter. Our planet is heated up evenly from all sides, with the current tilt and rotation, like you would roast a barbecue. It turns to the Sun with one side to warm it up, while the other cools down during the night. Were there no change of night and day, we'd probably only live in some areas of our planet where constant, never-ending twilight would be. Just imagine our life without those beautiful sunrises and sunsets. Maybe we'll just let it stay as it is, okay?
Chances are, we're going to find life beyond Earth by 2035, and there's no need to travel to a galaxy far, far away. Our Milky Way galaxy is full of totally suitable environments. Don't get too hyped up though. We're talking about microbes or chemical markers, not Hollywood-like green humanoids. Even so, when we finally find traces of life, it will change how we see our place in the universe. NASA's Kepler Space Telescope discovered something incredible. Almost every star has planets, and many of these planets might be habitable. Rocky planets like Earth and Mars are even more common in our galaxy than gas giants like Saturn and Jupiter. Also, we already know that our galaxy is very rich in water. There's water in interstellar clouds where stars and planets form, in the debris disks around other stars, in comets, just everywhere. What's really hard though is finding life itself. Ideally, to finally find it, we need to land on every single planet out there and literally check under each rock. But thanks to the newest research, we can at least narrow down the search to potentially habitable worlds. The James Webb Space Telescope, a super powerful telescope that was launched into space in 2021, is onto this. It checks the atmospheres of nearby super-Earths, rocky planets that are a bit bigger than Earth. It searches for life-related gases, chemicals that can only be produced by living things. And they already found some clues. For example, They detected signs of such a chemical on a planet called K2-18b. This planet is 120 light-years away, which is pretty close on a space scale. This planet is in the Goldilocks zone, which means a zone around the star where the temperatures are just right for liquid water to exist. It orbits a red dwarf star, the smallest type of star there is. Such stars are a bit fainter than our Sun. It will take about a year to check if these hints of life are real. If so, it would mean that life is much more common than we previously thought. But even if it's not, there are 10 more Goldilocks planets on their list to study. The James Webb Space Telescope is a very cool tool, but it has limits. It can't detect small Earth-like planets due to their size. To fix this, NASA plans to launch another tool, the Wide Field Infrared Survey Telescope. This one will be even better at spotting such planets and life-related chemicals. And also, we have the SETI project. SETI stands for Search for Extraterrestrial Intelligence. This project has been on a hunt for extraterrestrial creatures since the 1980s. They also believe that we'll find signs of life within the next 10 years. Not so long ago, they started a super big and cool project. It's called COSMIC, and it uses an array of radio telescopes in New Mexico. You might have seen those in the movie Contact. COSMIC allows scientists to listen to hundreds of thousands and potentially millions of star systems at the same time. If there are any interesting signals, scientists can check them right away, instead of waiting for weeks or even months. The signals themselves are often very sudden and short, but COSMIC can detect even the shortest ones that last nanoseconds. COSMIC can also help with other research, like studying mysterious and unexplained fast radio bursts, or even dark matter. This is the biggest and most powerful tool for searching for extraterrestrial life we've ever created. But it's not enough to just listen. Why don't we reach out ourselves? NASA has sent some signals into deep space. In 2002, their Deep Space Network sent a signal to the Pioneer 10 satellite. But there was an obstacle in the path: a white dwarf star 27 light-years away from Earth. If there's a planet around this star, perhaps the signal reached them too. If there are any intelligent species there, we could receive a reply by 2029. The DSN keeps sending powerful transmissions into space. These signals will bump into 222 stars within the next 3 centuries. Maybe someday we'll receive a reply from somewhere far away. But why haven't we received a response yet? There are about 200 billion galaxies in the universe, each with around 100 billion stars. If just 1% of those stars had one planet, that's still 200 quintillion possible planets. And we can narrow it down even further. If the chance of them having life is 1 in a trillion, that would still leave us a few 100,000 planets. So, where is everyone? This is a famous question known as the Fermi Paradox. The first possibility isn't that terrifying. It's possible that the universe is full of life, but this life isn't intelligent in our traditional sense. Some planets might have microbes, birds, or space dinosaurs. This is called the Great Filter Theory. It suggests that there are certain filters that life has to overcome in order to become intelligent, and maybe other species just haven't overcome them yet. Think about it. Life on Earth started in the ocean, then crawled onto land, diversified into many forms, went extinct in massive events 5 times, evolved again, and eventually led to humans. We built societies, developed healthcare, and only then started searching for another life. There's another idea called the Gaian bottleneck hypothesis, which suggests basically the same thing. While it might not be too hard for basic life to start, it's incredibly tough for that life to survive and thrive over long periods. Venus might have had oceans and Earth-like conditions too, but something went wrong. Its oceans boiled away because of a runaway greenhouse effect. Now it's sterile. Mars also had liquid water on its surface once, and both the Moon and Mercury had thick atmospheres for a short time. Meanwhile, Earth has had liquid water on its surface for almost its entire existence. It's super rare and remarkable for a planet to hold temperatures from 32 to 212 degrees Fahrenheit for millions of years. So, maybe it's a mistake to look for intelligent life, especially the one that uses the same technology as we do. It evolved under completely different conditions after all. That's also where the so-called Drake equation comes in. It's a formula that gives us a chance to calculate the potential of life becoming intelligent on a planet. To calculate the result, we need to know several variables: how many stars there are, how many of them have planets, the chance of these planets having life, and so on. Unfortunately, we don't know these numbers yet, and the result might be insignificant. But let's assume that there is at least one other intelligent species. Why haven't we met yet? There might be many reasons. Maybe they don't think we're interesting enough, or maybe the problem is with us. Perhaps we keep missing their signals, or maybe we missed the entire species itself. The universe is insanely huge and ancient. It's over 14 billion years old. If we compress Earth's entire evolutionary history into a 24-hour day, life starts at 4 a.m. Dinosaurs go extinct at 11:40 p.m. Human-like creatures appear 2 minutes before midnight. In this analogy, humans have existed for just 77 seconds, and our technology capable of detecting extraterrestrial life is even newer, less than a second. With such vast distances and time spans, the chances of us existing at the same time as other civilizations are slim. If their civilization lasted only a few millennia, we could easily miss them entirely. But that doesn't mean we should give up our search. Scientists were worried that Earth's radio signals had dimmed over time. But a recent study showed that it's actually the opposite. The numbers of our satellites keeps growing, and this makes our planet more detectable. By the end of the decade, we could have 100,000 satellites, making Earth incredibly bright in the radio spectrum. If there is an advanced civilization out there, they will easily spot us even from very far distances. Astronomers are super optimistic about it. There's a high chance they'll find extraterrestrial creatures while you and I are still around.
Uh-oh, hurricane alert! Everyone's hiding! The speed of the wind outside is more than 75 miles per hour. Seems like a lot, but this storm is moving at 400 miles per hour. Wait, do such speeds exist? Yep, but to see a storm that fast, you'll have to travel to Jupiter. So let the journey begin. The planet is huge. Almost 1,300 Earths could fit into this gas giant. It's also incredibly hot, with the temperatures reaching about 43,000 degrees Fahrenheit at the planet's core. Unfortunately, you can't land on Jupiter's surface because, well, being a gas giant, it doesn't have any solid surface. But you can go deeper into Jupiter's atmosphere. Look at these thick brown, yellow, red, and white clouds passing by. They're what make the planet look colorful and kind of striped. If you continue descending toward the center of the planet, you'll see its atmosphere, mostly made up of hydrogen and helium gas, becoming liquid. It happens because of immense atmospheric pressure. The planet's core itself is a mysterious object. Scientists still haven't figured out whether it's a molten ball of thick liquid or a solid rock 14 to 18 times the mass of Earth. Anyway, exploring Jupiter isn't the main goal of your trip. No, you've arrived here to see the Great Red Spot. It's an enormous storm raging in the southern hemisphere of the gas giant. Its top parts are towering more than 5 miles above the tops of the surrounding clouds. The storm is 1.3 times wider than our planet. In 2017, NASA's Juno space probe managed to collect lots of data about the red spot. And it turned out that this monster of a storm goes more than 200 miles down into the planet's atmosphere. That's 30 to 100 times deeper than any ocean on Earth. But these measurements are most likely imprecise, and the storm's true roots can be reaching even deeper. The Great Red Spot is colder than the rest of the atmosphere. And keep in mind that Jupiter's temperatures are minus 234 degrees Fahrenheit in the upper cloud layers. On the other hand, the closer to the core, the hotter it gets. Mysteriously, the highest temperatures ever recorded on the gas giant occurred in the atmosphere right above the Great Red Spot. There, the heat reached 2,400 degrees. This temperature is higher than that of lava on our planet. Astronomers believe that the turbulence caused by the storm might produce gravitational and sound waves that can be responsible for the superheating, but the storm itself is warmer at the bottom than at the top. People have been watching the moving vortex on Jupiter for more than 150 years. Some time ago, astronomers predicted that it would gradually slow down and become smaller or disappear entirely, but that turned out not to be the case. After having analyzed all the data received with the help of the Hubble Space Telescope, researchers were baffled to discover that the winds at the outer boundaries of the storm had actually picked up speed. The change in the wind speed is no more than 1.5 miles per hour during one Earth year. It's a tiny change, but however small the difference is, it still means a lot. The wind speed at the edges of the storm can reach a mind-boggling 400 miles per hour. That's faster than Earth's tornadoes. At the same time, if you found yourself at the center of the Great Red Spot, you wouldn't be too impressed. The winds there move way more slowly. Scientists faced lots of challenges when they were trying to understand the mystery that was the Great Red Spot. It's unclear what fuels the storm. Can it be the nature of the storm's home planet? Since it's a gas giant, Jupiter doesn't have any solid ground, so there's no friction, which might be the only thing that could make the storm weaken. The hot gases in the planet's atmosphere are always moving, rising, falling, swirling, just like on our home planet, where cooler and warmer air mix and merge into one another, forming giant circling storms. Astronomers think that once, several enormous storms could have come together and created the Great Red Spot. And now, it keeps going by constantly drawing cool gases from below and hot gases from above. Plus, the storm might be absorbing other smaller vortices. This makes the Great Red Spot even more powerful. Unfortunately, thick clouds on Jupiter don't allow astronomers to see what's going on in the planet's lower atmosphere. Scientists have been speculating on what may hide beneath the Great Red Spot for decades. Is it a massive volcano? Unlikely. Jupiter is mostly made up of gases, and it doesn't have a crust that could crack, letting lava escape from the planet's interior. There are also a few theories explaining why the storm has its trademark color. It varies from whitish and pale salmon to bright orange and brick red. Some scientists believe the answer lies deep below the Great Red Spot, closer to the planet's surface. A colorless layer of gas might be reacting to the UV radiation coming from the sun. This is probably what gives the storm its red color. But so far, it's just a theory. Hey, your guess is as good as mine, huh? Jupiter isn't the only planet that can boast having a giant storm. Another one, as wide as our home planet, rages on Saturn. It's called the Great White Spot. How clever! The storm has a tail of white clouds encircling the entire planet. It occurs every 30 years or so. The storm indeed starts as a spot, but then it starts stretching and stretching. Astronomers have figured out that the Great White Spot is actually a huge system of thunderstorms. At the top of the storm, lightning can flash more than 10 times per second. But the main mystery about the Great White Spot is where it gets its energy from. Some scientists think it may be powered by the sun. Others argue that the storm's cloud pattern only makes sense if there's an internal source of heat that can power the winds. Anyway, severe storms on different planets of the solar system aren't the only space mystery that makes astronomers scratch their heads. Let's move to Pluto, the largest known dwarf planet in the solar system, and explore its atmosphere. It rises really high above the surface of the planet and has more than 20 layers, all of them freezing cold and extremely condensed. By the way, our moon also has some sort of an atmosphere. Called an exosphere, it consists of helium, neon, and argon. It's 10 trillion times less dense than Earth's atmosphere. While traveling through space, watch out for black holes. Woo! A black hole is a place where gravity is so strong that even light can't get out. But black holes can sometimes behave like a massive galactic volcano. From time to time, they flare up. Sounds like me. But instead of spewing lava, they produce enormous amounts of energy. and this phenomenon leaves gaping holes in the surrounding material and gas. A short while ago, scientists discovered one of the largest craters in the universe. Radio and X-ray telescopes detected a supermassive black hole that threw a temper tantrum many years ago. It happened in a galaxy cluster about 390 million light-years away from Earth. The crater this event left behind could fit 15 Milky Way galaxies. Yeah, I can't get my head around that either. During your space voyage, think twice before landing on unknown planets. Otherwise, you may end up in a place like K2 141b. That's a planet outside of our solar system. At first glance, it's not that different from Earth. It has liquid oceans that evaporate, form clouds, condense, and get back to the surface as rain. But instead of water, it rains rocks. The surface of this exoplanet is covered with lava seas dozens of miles deep. The temperatures on the K2 141b reach 5,000 degrees during the day. That's toasty enough for the magma in the oceans to vaporize into the atmosphere. Then, supersonic winds, which can move at the speed of 1 mile per second, carry this rock vapor into the planet's night side. The vaporized magma cools down, becomes liquid again, and falls as a rocky rain. Not a vacation spot. Too hot. I'll pass. You switch on the light as soon as you enter a room. You never even stop to think about counting how long it takes for the bulb to light up. You couldn't. It's as if it's instant. Well, technically you could if you were fast enough. Good luck clicking that stopwatch in time when you're measuring over 670 million miles per hour. That's 180,000 miles per second. Almost the distance from the Earth to the Moon in the snap of a finger. Oops, wrong sound effect. Can you give me a finger snap? Yeah, that's it. In the snap of a finger. And the Moon's further away than you probably think. If all the planets in the entire solar system were lined up in one epic conga line, they'd fit between the Earth and its satellite. And that's including poor outcasted Pluto. Okay, light is fast. Moving on. It's a beautiful sunny day, perfect for a jog. And like any other day you go for a run, you stop and think, hey, I wonder what the speed of sound is. Don't you? Well, definitely not nearly as fast as light. Need proof? Check for yourself next time it storms in your area. You'll see lightning flash before hearing the crack of thunder. The light from that bolt rushed to you, zoomed into your eyeballs, and up into your brain for you to understand, oh, lightning. All the while, the sound wave from the thunder is still on its merry way to your ear. It'll get there, just give it time. By the way, thunder isn't the sound of storm clouds crashing together. It comes from that very same lightning bolt. It races toward the ground and rips a path through the air as it does. The air politely moves aside to make way for the lightning, and in the instant the lightning's gone, boom! The air comes back together and makes the sound we call thunder. Oh, and here's a fun fact. Sound travels faster underwater than in the air. A little over 4 times faster to be exact. So if you were to go for a swim with your friend and shout something bizarre underwater, they'd hear it a bit sooner than if you did the same thing outside of the pool. Uh-oh, everybody else heard it too. Oops. Sound also travels over longer distances underwater. It's why humpback whale calls can be heard for thousands and thousands of miles. But in a controlled environment where the air is dry and we have a constant temperature of 68 degrees Fahrenheit, the speed of sound is about 760 miles per hour. Now, that's a more realistic number, one that people can even reach. The famous Bell X-1 aircraft was the first to break the sound barrier on October 14, 1947. Test pilot Chuck Yeager was in the cockpit of the rocket plane. Imagine hearing that sonic boom for the first time ever in history. Bravo, Captain! Humans can race with sound, but light is a whole different challenge. For one, measuring it in the first place is no easy task. The official speed of light has changed several times throughout history, even going back to the 1600s. After centuries of debate and experiments with different results, the scientific community finally settled the matter in 1983. Maybe. To measure the speed of anything, you'll need to know 2 things: the distance between point A and B, and the time it takes for an object to travel between those points. With distance divided by time, you'll have yourself the speed of light. But with every experiment done to measure light speed, there's always been an extra cog in the wheel that everyone overlooked, or rather brushed aside. When doing an experiment using light beams and mirrors, we've always included the light beam's trip from A to B and back to A. With equal speed and equal distance, we have ourselves a controlled experiment and conclude an official speed number for the books. Case closed. Let's celebrate! Not so fast. A certain someone in 1905 had something to say about this, and that someone put a theory out there that light can travel different speeds going forward and back. Still can't wrap your head around it? Well, let's take this example. You had a long day. You pulled an all-nighter at work and can't wait to sink into your comfy warm bed. You get on a bus and head home. The night's clear and there's zero traffic on the road. Before the wheels on the bus can even go round and round, you immediately conk out in the back seat. But right before that, you checked the clock and saw it's exactly 10 p.m. What? After a big bump on the road jolts you awake, you become aware of your surroundings. But you suddenly find yourself in the exact same spot as the moment before you fell asleep. That was a quick nap. But then you look at your watch and it's now 11 p.m. You fell asleep in the bus and missed your stop. You'll have to repeat the exact same route all over again. Bummer. What can you determine from this? Since the whole ordeal took you an hour, you can assume it took exactly 30 minutes from the bus stop to reach your house and another half hour from your house back to the bus stop. Sounds logical, right? In our physical bodies, such a conclusion makes perfect sense. But it was Albert Einstein who challenged this idea. With his reasoning, the trip could have taken 59 minutes to get home instead of 30 and 1 minute back to the bus stop. Or even vice versa. Since you were fast asleep, there's no way you can know. And this idea is what's keeping scientists and physicists up all night throughout the decades. When you get into light speed in space, then the mind-blowing stuff starts happening. It takes approximately 8 minutes for light to reach Earth from the Sun. So, light is super slow in space? Not really. Now we're talking unimaginable distances. It takes 8 minutes for our sun's light to travel over 90 million miles to our planet. That's something to think about when going to the beach. The sunlight that made your tan lines traveled so far across our solar system to reach your skin. Ah, how thoughtful. And you can get sunburnt even on a cloudy day. That's how powerful our star is. Now, imagine yourself living on Pluto. I know, its planet membership got revoked in '06. But hey, call me old school. Our former furthest planet from the Sun is so far away, it takes 5.5 hours for sunlight to get there. No wonder it's always cold. The first planet in line is Mercury. The Sun's rays reach it in a mere 3 minutes. Hey, that's probably enough time to listen to your favorite song. By the time the song ends, you, the Mercurian version of you, will be basking in the sun's glory. It'll be impossible to listen to that track in space since sound can't even travel out there. You know, no one can hear you scream. Oops, there she is again. Music is just vibrating air, and without any air in space, sound can't travel. That explains why it's so eerily quiet out there. Okay, can somebody take the scream girl down the hall? And while we're up in space, let's pay our neighbor a little friendly visit. Alpha Centauri is the closest star system to our own. And what fun, the trip is just 4 light-years away. That's 25 trillion miles and 137,000 years on the road. Yeah, don't forget to pack a big lunch. To put all that in perspective, it would take around 5,000 generations in a super shuttle traveling through empty vast space to complete the journey. And we won't be able to come close to the star. Oh, and that's just one way. Okay, I think I'd rather come back to Earth now. Whew, that's better. Now, the longing question, how can we measure the speed of light without that little dilemma about the return trip? Oh, I got it. Why don't we just measure the speed with a super high-tech camera and map it out frame by frame until we're able to write down its speed? Well, nothing's as easy as it seems in the world of physics. Because when filming the light through a lens, we're not seeing the light itself, but rather a reflection of it. We just circled back to square one. Okay, scratch that plan. Then how can we prove light is going the same speed to its destination as its reflection is back to point A? Does the one-way speed have a defined value that's not a constant? Well, this is the ultimate question among scientists, and so far, there's just no way of truly measuring it. Unlike the speed of sound, which is more conceivable, the speed of light might just be light years ahead of us. Yes, just more fun light facts brought to you by The Bright Side. See the tie-in? Okay, never mind.
Scientists keep finding new planets they call super-Earths. It's a class of more massive planets than Earth, but way lighter than ice giants, such as Uranus and Neptune. Super-Earths can be made of rock, gas, or a combination of these two. They are often twice or even up to 10 times bigger than the Earth. They're interesting to study, but kinda too far away from us. They're pretty common outside of our solar system, together with other interesting planets like mini Neptunes. Those can also be gas dwarfs, ice giants, or huge rocky bodies. But again, we don't have anything like that. But something we do have that those other solar systems don't? Jupiter. It's the biggest and heaviest object that orbits our sun. This king of planets possesses a powerful force to dominate our solar system. Jupiter is notorious for eating planets. A protoplanet slammed into it about 4.5 billion years ago, when Jupiter was still a young planet in its early stages. This protoplanet was 10 times heavier than Earth and was made of ice and rock. The collision was huge. Jupiter's core broke apart, and helium and hydrogen mixed with denser materials. Through time, the heavy material settled back into the dense core, which is what we see today. And if it swallowed a planet before, it might keep doing it as well. We suspect our solar system used to have many more large planets than it has now. For example, it's kinda empty around Mercury today. Similar areas around many other central stars are definitely more packed with intermediate mass planets, with the size between Earth and Neptune. Our solar system was a chaotic place at its beginnings. Young stars were surrounded by swirling disks of dust and gas, and planets would form out of that debris, something like trees when they're springing up from the ground. Small rocky planets would form in the strong heat and light close to stars, while gas giants would form farther out, where temperatures were lower, which means they could preserve more gassy materials. And even though planets in our solar system seem pretty stable and peaceful today, following their orbit, they weren't that calm before. Some planets didn't have a circular orbit. They had oblong, more eccentric paths. It took them swinging first toward their stars and then farther away. It was like they had been thrown off kilter by the gravity of other planets on their way. There's something called the Grand Tack theory. It explains things happening in the first few million years when our solar system was forming. At some point, Jupiter, one of the key players here, may have been pulled in closer by our central star. After that, it went back and took a huge cloud of debris. It was like a sailboat when it tacks around a buoy. This kind of messed with planets that were in the process of formation. After Saturn was fully formed, our close neighbors in the solar system cleared out a little. But if the idea about Grand Tack is correct, Jupiter had grabbed everything in its way, and its migrations had caused more collisions in this area. Jupiter might have delivered some of the water that now fills the oceans we have on our planet. It shepherds plenty of asteroids. From time to time, it sends some whizzing into interstellar space, or amongst the planets in our solar system. It may have even taken part in the dinosaur extinction 66 million years ago. When the huge space rock hit the Earth, it left a crater off the coast of the Yucatan Peninsula in Mexico. It all caused earthquakes, volcanic eruptions, and tsunamis that made a huge impact on all animal and plant life on Earth. No one knows where it came from. We're not even sure if it was an asteroid or a comet. One theory says it may have been a comet that came from the Oort cloud, which is made of icy debris and is located somewhere at the edge of our solar system. It could have been bumped off course by Jupiter and its powerful gravitational force. This way, our solar system was like a pinball machine, where Jupiter, the biggest planet, kicks incoming comets into orbits that send them closer to the Sun. When these comets are near the Sun, they can go through strong tidal forces that break them apart and eventually create shrapnel-like pieces of a comet. That event was a point when our mammalian ancestors started to rule. That means without Jupiter, there might not be us either, nor the Earth. It seemed like our biggest planet came swinging in, destroyed older planets, and cleared the way for smaller worlds like ours. Jupiter may have been the reason why we can't find Planet 9 right now. Scientists believe it exists, and they think it could be hiding somewhere beyond Neptune, but not Pluto. There are 3 zones in our solar system: the inner planets, outer planets, and whatever there is beyond. The mysterious planet could be the size of the Earth or Mars. It swirled among the gas giants before they eventually swept it toward the outer parts of our solar system, or even somewhere into deep space. Jupiter has stripes because of differences in temperature, atmospheric gas, and chemical composition. Scientists used to think the only reason for these different colors was the mighty atmospheric wind and material circulating between layers of the atmosphere. Now we know the light-colored stripes, or so-called zones, show us where the gas rises. When the stripes are dark-colored, they're called belts and can tell us where gas is sinking. Jupiter's moons could also be why the planet is stripy, because they're tugging on its atmospheric convection cells. At the center of Jupiter, there's a dense liquid core made of helium and metallic hydrogen, together with dissolved heavier elements. As we go further from its center, the temperature and pressure inside the planet drop off. That way, the liquid interior gives way to gases from the atmosphere. Again, mostly helium and hydrogen. No one knows how deep this liquid-gas boundary lies, but the planet is probably fully liquid a couple of thousand miles under its cloud tops. Jupiter would still be bigger than some other giants, like Saturn, if we could strip its gases. Jupiter is sometimes even called a failed star, although that's not quite correct. It's mostly made of hydrogen, like regular stars, but it's still not massive enough to start thermonuclear reactions in its core, which would eventually turn it into a real star. In theory, every object could be turned into a star if you only add enough matter to it. If there's enough mass, the temperature and internal pressure will increase and start thermonuclear reactions. So, to turn Jupiter into a star, such as the Sun, you'd have to make it 1,000 times more massive. But to form a cooler red dwarf, you'd only need 80 Jupiter masses more. That way, Jupiter won't spontaneously become a new star of our solar system. But if many space objects with similar mass collide with it, or in other words, if Jupiter eats them, then maybe. You never know. But in theory, if it could become a massive star, it would have stopped other planets from forming in stable orbits. It would have also increased the radiation that the surface of those planets get, which is why it would be really hard for life to develop in our solar system. Jupiter is the planet that spins the fastest in our solar system. It only needs 10 hours to make a full rotation on its axis, even though it's huge, more than 300 times bigger than the Earth, and 2.5 times more massive than the rest of the planets in our entire solar system together. But if it got more massive, it would shrink. More mass would make Jupiter denser, which means it would begin pulling in on itself. So it could get 4 times its mass and would still be the same size. The speed of light is the fastest thing in our universe. It travels across space, passing through Mercury and Venus to reach us, and it's slowing down. No need to panic though. The sun is getting weaker, but we won't see the effects of it for another billion years. In the vacuum of space, the speed of light is around 186,280 miles per second. Any slower than that, and humans would see the changes firsthand. There would be some awesome effects, like colors changing and the brightness of objects fading. We'd also notice some differences in everyday objects, their length and shape. Scientists created a simulation to see what would happen if the speed of light was slower. In a vacuum, the speed of light can't change, but if light passes through different materials and objects, it alters the way we perceive things. Light acts as a wave and a particle, meaning that it's a wavelength. The color and frequency are determined by the distance from crest to crest in the wave. It behaves similar to sound with the Doppler effect. Imagine you're standing in the middle of a busy highway and a honking car speeds through. Wow, that was loud. You can hear that whoosh-like sound of the horn because the moving object produces the sound while you're stationary. The frequency and pitch seem to change, but it's just the sound reaching your ear faster than it would if you and the car were both stationary. Light behaves similarly. The wavelengths change if the speed changes. Moving toward a light source and making the wavelength shorter will shift the color to a blue and violet hue. Moving away from the light source, and you'll get something more reddish. So if the speed of light slowed down to walking speed, we'd notice the colors changing when we approach an illuminated object. At the same time, the color would change around us and behind us. If you walk sideways, the colors you're walking toward would become bluer, and everything in the distance would become red. This information is useful to astronomers who are studying objects in space. If they're blue shifted, that means the object is moving towards us. And if it's red shifted, then it's going in the opposite direction. In fact, everything in the universe is red shifted, proving that the universe is expanding and getting further away from us. The slower it gets, the brighter it becomes. That's because the photons become more present for us to see. At this rate, we can see invisible light and increased intensity. You won't notice that effect much if you're standing still, but because of the Doppler effect, moving towards an object will have different colors and different light intensities. Another phenomenon we'd experience is time dilation. It's when you move at a similar speed as light and time decreases relative to someone who isn't. Space and time are relative. So if you're sitting at your desk wasting hours away, yeah, sounds familiar, doesn't it? All your movement will go through time and not through space. You're stationary, but you're still technically moving forward in time, slowly aging. The faster you move through space, the slower your movement through time will be. If you move at the same speed as light, then all your movement will be through space and not through time. To notice that, you'd need another person to watch you. You're not in a time machine. You're both on Earth, experiencing the same time flow. To you, experiencing this firsthand makes it feel like you're going faster, because you're getting a lot more movement in space in a given time. The closer you get to the speed of light, the smaller you become. Well, not really, but it depends on who's watching. If you're the one traveling at such a speed, an object nearby will seem small, just as someone who's watching you travel at the speed of light will think that you're smaller than you actually are. The simulation that the MIT scientists conducted showed that if the speed of light drops, everything will become stretched out like a pancake. If you see mountains in the distance and then run at the speed of light, they will appear further away. Objects will become distorted, and it will feel like you're getting to a certain place faster because time has slowed down for you. If you're standing completely still and someone standing on your left-hand side throws a cube-shaped object over to your right-hand side, then naturally, you'll see one side of it unless it flips around. But in this new reality, you'll get to see the front side wrapping around the visible side you're seeing. If you're moving at the same speed as light in an infinite space, everything will be stretched out as you reach infinite speeds. In a world where people can walk at the same speed as light, we'll perceive nothing as normal. We'll have to get used to the way we see objects. Every movement we make will result in drastic shifts of colors. Even turning your head to look at something will feel weird. Let's say you're in a supermarket buying groceries, and you walk from aisle to aisle. The milk at the end of the counter will look like it's really close to you. But when you approach it, you'll start to feel like it's getting further away from you. The milk will also look a bit red. As soon as you get closer to it, it will shift to blue. If someone is passing through with a shopping cart, you'll see it as a sort of 3D model of a shopping cart. The color will shift as it gets further away from you. It will appear far away, but it's right in front of you. In fact, we don't really know the actual speed of light. Physicists gave it roughly 186,280 miles per second, but that constant is just for them to calculate other scientific stuff so we can understand it better. The problem is that we can only measure light with light beams and mirrors, but it's not like all we have to do is point a light beam at a mirror and measure its original path and its reflected path. Einstein's theory of relativity states that the original path of light moving from the source to the mirror may not be the same speed as the reflected light from the mirror back to the source. Hypothetically, If it takes light 10 seconds to travel from the source to the mirror and then back to the source, then we can conclude that each trip takes 5 seconds. But Einstein's theory is that it could take 9 seconds for light to travel from the source to the mirror and only 1 second from the mirror back to the source, or vice versa, or maybe completely different numbers altogether. That's why it's so difficult to measure light. A breakthrough came out for scientists when they managed to slow down the speed of light to 0 without losing its brightness. They did this by using ultra-cold atom clouds made with photonic crystals. These crystals are materials punctured with billions of tiny holes where light can refract. But what if we lived in a world where light stopped halfway? You'd wake up one morning and feel like it's twilight. You'd open the curtains and see that many car lights are on, but aren't so bright. You turn on the lights in your room, but feel like the bulb is tapping out. You replace it with another one, but it doesn't do the trick. You turn on the lights everywhere in your house, but it's all just giving weak light. You're confused and try to check if there's a problem with the electricity in your house, but it seems to be working well. You check on your neighbors, and they also have the same problems. Even experts in the field can't understand what's going on. Hours pass, and it's all the same. All the light in the world seems to have frozen halfway. Your phone is low on brightness, even though you bumped it up to maximum. Everything is getting darker. You learn from the news that it's a global problem. Light is slowly diminishing, and soon there won't be any of it in the world. You decide to wait it out while everyone else is panicking.
Whoa, something doesn't feel right. Everything seems shaky. It's definitely not an earthquake, and it's actually getting worse. The clouds seem to move quicker than usual, and the animals are going into a frenzy. The news anchor pops up on the TV in an alarmed tone and says, "Good morning. We're sorry to interrupt your program. Scientists have just discovered that the Earth's rotation has been fluctuating at an unusual rate. A group of specialists believe that the Earth is increasing its rotation with every second, and they don't know why. Even if the Earth increased its speed by 1 mile per hour, the day would only get shorter by a minute and a half or so. We wouldn't really feel it, and you could go on like nothing is happening. But as the Earth spins faster, our bodies, which are adjusted to a 24-hour timing, will have a hard time trying to cope with it. If you live by the equator, that means the rotation of the Earth is going quicker than at the North and South Pole. The area by the equator needs more time in order to complete its full rotation from the starting point. You'll experience more rain than usual. The Earth's rotation keeps the weather consistent and balanced so that nothing abnormal happens. But because the Earth is moving so fast, the weather is acting up. We'll start to see more storms and more cozy days inside, sipping on hot cocoa. Even though it seems weird, everyone can go about their day. But if the Earth picked up some speed and moved at 150 feet per second, the day would be reduced to only 22 hours. It kind of makes you feel jet-lagged 24/7. Every business works with the 24 hours a day schedule, so taking away even 2 hours can have catastrophic effects on the world economy. The whole calendar will have to change and adjust to the new timing. Clock designs will change with the new midnight, replaced with 10 o'clock. And with each week, the hours will shorten, so there will be no proper way of telling time except by sunsets and sunrises. The weather will continue to get worse and worse, feeling like the rain will never stop. The animals that rely on weather patterns won't know how to function, and mass migrations will occur from almost all species of animals. Flocks of birds will be flying everywhere and reach places they normally won't go to, affecting the whole food chain and ecology. Woods, jungles, and other places where animals roam are kept in proper balance when unaffected by humans. If it constantly rains in certain areas, then floods will force animals to move to other territories and compete with the predators in the area. If the Earth picked up speed every day, then standing on a scale in the Arctic would tell you weigh 180 pounds. But around the equator, you might weigh about 179 pounds. That's because of the extra force opposing gravity in that area. With the Earth spinning faster, all airlines around the world stop, since the radar systems have gone haywire and the weather is too dangerous to fly. Everyone has to get around by car. Satellites are positioned in such a way that it's crucial they remain where they are in order to bounce signals to us. Because of what's happening, Wi-Fi and TV signals can't go through. Communications around the world will end up short and slow, and eventually we'll have a total communication blackout. Ships will cease to operate, and global trading will collapse, adding extra damage to the already failing world economy. Winds will get stronger and faster than usual, which means temperatures will change. Storms like hurricanes will be stronger than ever and have more energy for destruction. And still, at 100 miles per hour, the equator will now be swallowed up in the water. The Amazon basin and small islands will now completely submerge in water by around 50 feet. Most of the plant life will be endangered, especially by the equator. With woods threatened by floods, more animal environments will be in jeopardy. The trees and plants won't survive so much flooding. If the Earth rotated so fast that the hours would now be reduced to 15, then we'd probably feel like we're always on a jet plane going through turbulence. It would be impossible to sleep if the Earth kept picking up speed every second of the day. So days would be around 7 hours long as well as nights. The whole world would be flooded, except for the highest points and the tallest mountains. If that happens, humans will most likely end up there clinging to the last remaining clear patches of land. Most of the animal life will be extinct as well. And as the Earth is spinning faster and faster, the crust will lose its durability, allowing more frequent and stronger earthquakes to happen. Volcanoes will erupt all over, even if they're submerged in water. It'll go on like this for quite a while. Many major natural disasters like earthquakes, tsunamis, volcanoes, and even melting ice sheets have sped up the speed of the Earth by milliseconds. So, with the Earth's continuing speed increasing, these natural disasters will make the planet go even faster. Even if it's just for milliseconds, it's enough to have major consequences. The Earth is now spinning at 1,000 miles per hour, and as you're sitting with the rest of the survivors, you feel yourself levitating slightly. You'll see tiny pebbles and rocks floating inches from the ground. The clouds above you are passing like shooting stars. The air is thick with moisture, since water is rising to the top, forming thick clouds ready to pour. But since gravity is weaker, some of the rain is suspended in the air. Many small objects will be floating around as if you were in space. The days and nights won't be longer than a few hours. At this point, the whole world will be flooded, and the crust will be 80% gone. If it goes on any longer, there won't be any living things around, probably except for microscopic creatures that can withstand extreme and harsh conditions. The Earth would need to spin at approximately 17,600 miles per hour to cancel out the gravity for things to start floating around. At this point, all the water in the ocean will rise and look like reverse rain. The large mountain rocks will separate from the bedrock and levitate above the ground, looking like little planets in space. The Earth is now spinning 17 times faster than usual, which makes one full rotation around its axis only 84 minutes instead of 24 hours. If you manage to stay that long, then you'll literally see the days and nights go by in an instant. You'll also be floating aimlessly in the sky, bumping into rocks and other surfaces. You won't recognize anything anymore. The Earth's crust is ripping apart, exposing the magma underneath. So landing on the ground isn't an option. You'll see outer space as you go higher and higher. You won't know how fast you're going, but all you know is that you're probably the only human left in this spinning world. The Earth will eventually spin so fast that the rest of the layers will start to peel off, exposing the Earth's interior. It'll start to squeeze itself from the core until it becomes similar to a pancake. Nothing can survive at this point. So much heat will be produced from the core that the planet will heat up like a microwave. All the water will disappear, and it'll look like a red dot in the solar system. And once it starts to approach the speed of light, time will freeze. The rocks and floating elements won't move and will eventually be distorted. And with enough effort, the Earth will eventually turn into a black hole. Of course, nothing like this will ever happen. According to scientists, Earth will most likely slow down in rotation. Ever since the Moon came into the picture, the Earth has been slowing down by around 4 miles per hour every 10 million years or so. That's because of the Moon's gravitational pull on our little blue planet. It'll most likely go on that way. So hey, what's your hurry?